name is Bob Sharf. I'm chair of the Center for Buddhist Studies, and on behalf of the center, I'd like to welcome everyone to this workshop on Buddhism, Physics, and Philosophy, Redux. So the roots of this workshop go back to a conference organized by Marcelo Gleiser, who's with us today, in Dartmouth in February 2019. I proposed a conference on Buddhism and physics over lunch with a number of the folks who are here today, including Evan and Chris and Adam and Jinan, if she's there. You are. I admit I was surprised at the enthusiasm, not only of that original group, but of all the people who ended up being invited to the conference. And it was originally planned for April 2020, and then postponed 2 or 3 times. I've literally lost count. So I want to begin by thanking the participants for hanging in there over the past few years and not letting the pandemic dampen their interest. I'd also like to thank the foundations that provided funding for this event, the Tingzong and Weifeng Zhao Foundation, Bukyo Dendo Kyokai, Glory Sun Global Buddhist Network, and the Tianju Global Network for the Study of Buddhist Cultures. And also a special thanks to Sanjot Mahendale for handling all the preparations, and to Sky Van Valkenburg for handling the IT. They do a great job. Now, as I said, I was legitimately surprised at the level of enthusiasm of those who were invited to participate. And I confess that my surprise was tied to certain reservations that I myself had, and indeed have, about venturing into these waters. As I'm sure the audience is aware, there is a large literature on the subject that can be traced back to 2 popular books in particular, both of which appeared in the 70s, Fritjof Capra's The Tao of Physics, an exploration of the parallels between modern physics and Eastern mysticism, and Gary Zukav's The Dancing Woolly Masters, an overview of the new physics. And these were followed by, among others, Goswami's The Self-Aware Universe, How Consciousness Creates the Material World, and Evan Harris Walker's The Physics of Consciousness, The Quantum Mind, and the Meaning of Life, as well as additional books by Capra and Zukav, and many more, including in the 2000s, the Dalai Lama's book, The Universe in a Single Atom, The Convergence of Science and Spirituality. Despite, or perhaps owing to, the appeal and success of these popular books, this area of scholarship has acquired a rather tawdry reputation among scholars in my field. And I suspect this may be true for the physicists and philosophers as well. They can correct me. When I mention my interest in physics to my colleagues in Buddhist studies, I can feel the skepticism, if not the scorn. It seems to confirm their suspicions that in my dotage, I have given up on serious scholarship and am putting myself to pasture. So I wonder if any others have had a similar experience. So the skepticism, I would like to suggest, is not entirely unwarranted. Now, it is not that the parallels many see between strands of Buddhist thought and strands in modern theoretical physics are not real. Anyone who has more than a passing familiarity with the problems that preoccupied Mahayana Buddhist scholiasts on the one hand, and quantum theorists on the other, immediately recognize the parallels. Both the Buddhists and the physicists wrestle with notions such as the independence of observer and observed, or mind and world, with how to understand relationships without relata, with causality, determinism, and the felt passage of time. The question is not whether there are similarities, but rather, so what? Interdisciplinary work is hard enough. We know how difficult it can be to bring anthropologists and psychologists and economists and philosophers together, for example, to discuss issues that all of them will agree are of common concern. So even if we agree that theoretical physicists and Buddhists have been struggling with the same conceptual quandaries and have explored similar conceptual pathways, there is no guarantee that fruitful and productive dialogue across these disciplines is possible. So the goal of our workshop, at least for those who agree with me, is to try to speak across our disciplines and see what emerges. To that end, we have allocated each speaker an hour, but our hope is that they won't take more than 30 or 40 minutes for their presentations to allow plenty of time for discussion. We also hope that they will do what they can to make their work accessible across disciplines without dumbing it down. And this means translating technical language and jargon whenever possible. And at the end of each presentation, we're going to open the floor first to the other presenters, and after that, time permitting, to the audience. And timekeeping will be in the hands of our randomly appointed chairs of each panel. And with that, I turn this over to Adam Frank, who will chair the first panel.
I'm going to say that the first speaker is Carlo Rovelli, who will be speaking on that topic.
Thank you very much. Thank you, all of you. It's an honor for me to start this this meeting, and also difficult task because of the diversity of the people gathered here. It's a remarkable collection of minds that I enormously admire. Really good. So it was very easy to me to decide how to organize this. In spite of the title, I'm going to talk a little about Buddhism because I'm incompetent, and much more about physics, where I'm supposed to be competent. But I want to talk about the kind of connection between the two that it became significant to me at some point, and to try to find a language that could be understood. People coming from different contexts, I decided to go sort of in time in my own path of understanding all that. So I'll follow a sort of chronological order from telling you the way I thought about quantum mechanics from the 70s when I understood it to now, and what are the different ways I looked at the theory and what it meant to me reading Nāgārjuna. So let me start from my first encounter with quantum mechanics was in the 70s, and I studied it through this book, which is an Italian translation of Dirac Masterpiece, one of the greatest books I think in the history of science, Principle of Quantum Mechanics, which gives a presentation of the theory. First edition is back in the 30s, then a number of editions, just not sure it got better, but with astonishing clarity. And when I studied it, I was amazed by the theory. I was amazed by the world that the theory described. I was astonished. I was in my 20s, so full of enthusiasm for evolution and for something new. Here it was. But I found it very clear, remarkably clear. I spent 2 months immersed in this book entirely. I have to say that I used a number of other books on the side, but that was the main one. And given the contemporary climate, I want to say that the main second book is Landau, a Russian physicist who also was one of the clearest thinkers, I think, of that generation of thinkers. And then the physics of Berkeley, I'm happy to say it's a peculiar take into physics. Of course, Feynman always has a way to clarify things. Now, that's the theory that I learned at the time, and that's the theory that, one slide, which I still think is the best way of thinking about quantum mechanics. And that seemed so clear to me. And I learned, as what the scientists before me had best understood as a way to think about the world out there. What's peculiar about the theory is that it's formulated in terms of observations. And that's somehow point number one, characteristic of quantum mechanics, and it's going to be much of what I'm going to say about it. And an observation is expressed as the value that a variable of a certain system takes, or values that variables of systems take. There are three notions here: system, variable, and value, which I'll come about in a moment. These are discrete observations, so that's peculiarly different than the way we use in quantum, in classical theory, classical mechanics to describe reality. So these are not variables that evolve in time or anything like that. They value the observation given at some given moment. And what the theory allows us to do is to compute probabilities that, given certain values of variables, what is the probability of in another observation, which can be later or even earlier, or related somehow, we would find a value here. So let me go through these three notions because they are key. First one is system. And I want to stress one point, which in my opinion is extremely important, and it's a source of confusion, and it's core to what I'm going to say. The system in quantum theory is not an elementary system. Quantum theory is not about the elementary constituents of the world. Okay? A system is not an elementary form or anything like that. A system is an atom, a molecule, a star, a planet, a pendulum, a Josephson junction, the sun, the atmosphere. That's a system. Okay? So it's part of the world that we, allow me to use the word convention, bring together and describe using pragmatism. Okay? And the system is characterized by a set of variables. Okay, a system has variables. So the system has variables. This is the position, a velocity, a color, a weight, whatever, okay, which are related to one another. The job of the physicist is to know this relation, functionally related to one another. Well, the energy is the velocity squared divided by whatever, 2 times the mass. So the set of variables that characterize a system heavily, to the extent we are describing a set of relevant variables. Okay? In general, systems have many other variables which are not part of the story because are assumed or considered or genuinely taken to be irrelevant for what we do. So there are these variables, and a system is characterized by these variables. A system is its variables. Okay? We don't say anything else about the system in the theory than the list of variables and their relations. And when there is an observation, remember, all this is about observations, variables take a value, and it's confusing if you confuse the value with the variable. So the variable is the position, the value is 3 meters from the floor. Okay? That's the conceptual structure. And then there's the mathematics that allows to compute these probabilities. And I'm not going to give a lecture on mathematics, it's not really important for what I'm going to say. Let me just say the main point. This variable, given a system, this set of variables, we associate with this variable a mathematical quantity that we use to do calculations, and that's the core technicality, that's the core technical point of quantum mechanics. These are non-commuting variables. These are elements of non-commuting functions. Namely, we can do calculation with that, but H times B, we assume is not necessarily equal to B times A. And since the variables have a relation among them, for every degrees of freedom, and allow me to a little bit of technicalities here, you can express them in terms of sort of position and momenta, two basic variables for every degree of freedom. And the main equation of quantum mechanics, in fact, the only equation of quantum mechanics, I would say, the only equation of quantum mechanics in addition to classical physics, because you can do quantum mechanics just the same equation of classical physics plus 1. This is 1. So, which says how much x and p do not commute. X times p is different than p times x, and the difference is h bar, which is the main constant of the theory. Now that's all. With that, everything can be computed, and in particular, given any variable, the theory, this mathematics, tells a list of values that you can have, which is its spectrum, the element of the spectrum that technically is the number A such that this parenthesis cannot be inverted. And with that, you can do some calculation. This is known as algebraic probability, given is something else. I'm not going into the mathematics. But that's sufficient. There's no commuted algebra is sufficient for computing this probability. That's it. Things that distinguish this from classical physics. Because variables are classical physics, systems are classical physics, values are an observation of classical physics. And what's the difference? First of all is discreteness. And there are two aspects of discreteness here. One, I just mentioned, typically variables cannot take any value. Can only take certain values. And I would say generically, because always, unless you assume something infinite, if you assume that the phase space of the system is infinite, you can get continuity, but that's an idealization. So outside some idealization, variable can take only certain values and others, but more important, the observational is continuous. Okay? Quantum mechanics is about instantaneous observations. It doesn't assign probability, it doesn't talk about an evolution of a variable in time, unless you make a complicated story about that. Second, we talk about probability, and probability is intrinsic in quantum mechanics. Let me say this strongly, even in those interpretations of quantum mechanics which are called deterministic, like many worlds or hidden variables. Because they have a sort of deterministic ontology, but this doesn't change the fact that for reasons which are different to one interpretation from the other, what we can predict, say about the future, is limited, not limited in a way that can be arbitrarily precise, but limited sharply by H1. Hidden variable theory, because some variables are hidden, and so we cannot use for that prediction. In many worlds, interpretation, because we don't know the lexicality of lexically which branch we're going to be when we make the next measurement. If you're familiar with these things, if you're not, it doesn't matter. So probability is a core part of the theory, independently of how you think of it. And relationality, I'm going to come back, of course, to that, because most of what I say is about relationality. The theory doesn't mention, and that's the key point, variables having value by themselves, but mention variables having values in observations. That's in the foundations of the theory. Okay? So this quantum system has a value because somebody's looking at it in some sense. Now, when I studied this, as I said, that seemed clear, fantastic. How strange is the world? How beautiful is the world? How different from my classical, what was told by high school teachers before. But come on, let's test it. In the 80s, I did quantum gravity, so I didn't worry about quantum mechanics, or I worried a lot about quantum mechanics, but as a tool. Of course, to do quantum gravity, you have to try to digest well quantum mechanics, so you can use it to understand the quantum properties of space-time, gravity and space-time. So I focused on that. There are issues, but the core thing remains the same. There are issues, for instance, about temporality, how to describe time evolution in that, and that's the kind of thing. You have to slightly generalize the standard formulation of quantum mechanics, not much, to allow the specific way of dealing with temporality, which is a general relativity, but I've already done it in the way I presented it. In fact, if you notice, I didn't talk about time. You don't need to talk about time. That's another thing. Then, in the 90s, I started to have doubts. And contrary to sort of stereotype, I got my doubt going from Europe to America. I got to America in the beginning of the 90s, January 1st, 1990, arrived in Pittsburgh, and started my new life in Pittsburgh. And I was under a number of influences. One was the HPS, and the Department of History, Philosophy, and Science in Pittsburgh Center, and which is a fantastic place for philosophy of science, for American philosophy of science, because they're great people, but also because everybody's going through that, or was going through that. I think it's still going through that point. So I was sort of deepening an ancient fascination with philosophy that I've always had since high school. I've been reading philosophy since all my life. But there I could just talk and listen to a lot of philosophy going through. That was one influence. A strong influence was John Wheeler. John Wheeler got excited about the quantum gravity. He invited me to Princeton. I had a lot of conversation with him. And of course, for John Wheeler, the quantum was a mystery to understand. And John Wheeler was my idol in quantum gravity. I so much for him, and he considered the quantum a complete mystery. It seemed totally clear to me. I mean, clearly he was seeing something I was not seeing. And then my main colleague in Pittsburgh was Ted Newman, who is a fantastic scientist, a great relativist, one of the greatest scientists that I think of that generation. He's the one who cleared up the mathematical black holes. And he was always telling me, Carlo, you really believe in the same quantum mechanics? I don't. Okay. Quantum mechanics make no sense at all. Zero. And I was saying, come on, Ted, it's simple. Look, this, it's fine with you. He says, no, it doesn't make any sense. Now, of course, what was going on was he's a scientist with a profoundly strong realist intuition about the world, and the story I gave didn't make sense to him because it was missing this realist what is going on out there concretely. And then there was under many other influences. My companion at the time was under the influence of Varela and Nāgārjuna and system theory. So there was more all sorts of things. I listened to more John Griffiths on the history of gravitational quantum mechanics, so on and so forth. And I started having doubts, and the doubts are the obvious questions that you can ask, given the way I presented things. What happened if there is no observation? It's the simplest question you can ask. It's just about observation. And if not observation, the universe got shut up and waits for somebody to make an observation. It doesn't make any sense. And what is an observation? What distinguishes an observation by something else? I mean, if a cat is smelling a mouse, is that an observation? If a stone is hit by another stone, is that an observation? If a tree gets some light, is that an observation? I mean, what is an observation? And what is observed? Does it have to have a Ph.D.? It has to be a novel? What's the point of an observer? And of course, the obvious questions, I stress it strongly, variables have value at observation time in the formalism. Variables have a value when they're not observation. And 1 second, these are the two main strategies which are on the table for answering these questions, which I want to stress, they are also scientific questions in a deep sense. I mean, it's like asking, is the Earth the center of the universe? This is a scientific question, which doesn't have an empirical answer. How you measure things is the center of the universe. But it's a scientific question because if you choose one or the other, you orient your entire conceptual structure differently. But these are good questions. Now, the two main strategies, I'm not sure pragmatic is the right name here. So how much do you try something here? You can say, depending, you can turn this way, you know, empiricist or Kantian mission. But somehow, under the spell of the great fathers, Niels Bohr, you can just, in some sense, answer no to this question, negatively to these questions, by insisting that when we do science, what we're doing is making sense of the observations we make. A strong Machian perspective. Namely, that's what science is about. We observe a number of things, we connect them, and we make a coherent way of dealing with this. So it's not really meaningful to ask what is independent observation, because this is what we're dealing with, the ensemble of these observations. And the observer is necessary as a starting point for doing science, and so on and so forth. And again, you can turn this in different ways, just in a sort of basic empiricist way, or accounting. This is a priori condition for. Of course, now the champion of that in the early discussion in the 30s about quantum mechanics is Einstein himself. Who always reacted saying, wait a minute, to do scientists, you have to some degree be a realist. You want a story of what happened in the world. You want a story there also what happened when you're not observing something. Because that's how science is a powerful tool, if you want to play in the weakest possible way, it's a powerful tool in the way science has always been successful in describing the world. And this is possible. You can create a story out there. And some of my best friends and colleagues take it very seriously and have stories, very nice, beautiful stories of what happened beyond this observation. Two very good examples, hidden variables, the David Bohm story, or many worlds. Many worlds is a quantum state, it's a huge wave function, happening all there, evolving in some general Schrödinger equation, or Wheeler equation, whatever, and the observation are just some sort of epiphenomenon out of this huge wave function. So you can add to the core structure of the theory that I presented before, this, allow me to misuse word, this ultimate reality out there and make a credible story. If you do that, you certainly gain a lot, because you don't need to consider observations very peculiar, strange, fundamental things. The things just happen to interact, and in some sense, everything is an observation, or some particular interactions with some properties, maybe the coherence, whatever, count well as observations. The observer is no system in particular. In both cases, careful, in both cases, it remains the fact So in both cases, you remain radically different than classical theories because variables don't have values besides these observations interactions. And one way to trace back this way of thinking, one could trace it, this one to the Göttingen school. This is Heisenberg, of course, maybe even more than Heisenberg, Max Born, who was, I think, the real mind of the Göttingen school. That's the way Dirac and Born put the theory together, while the realist way was certainly in the early Schrödinger intuition. Schrödinger is a deep thinker, so he changed many times about thinking about quantum mechanics. But at the beginning, he was saying, oh, let's put this out there, with this wave that it goes, and so on and so forth. And nowadays, somebody can recognize himself here.
I was younger. I was much younger.
Yeah, you were much younger. You were prettier. And Michel Bidvor, and so these are different ways of playing this game here. These are well-known realists. All right. So that's a question I asked myself at the time, and your time is intended. Between these two positions, each of one having some attractive aspect, but each one had something that didn't make me happy. Is there a middle way? And I think there is a middle way. And I got more and more close to a way of thinking which is in between the two, which I want to introduce, and I'm now going to the core of what I'm saying, by referring to a paragraph of Niels Bohr, which I think captures the core of what is actual discovery, physical discovery, of quantum theory, in a very insightful way, and in a very misleading way at the same time. So what I want to do is to read it to you and tell you why I think it's insightful and why I think it's misleading. So here it is. Whereas in classical physics, the interaction between an object and the measuring apparatus, this is what can be overlooked or can be taken into account and compensated for. In quantum physics, this interaction is inseparable from the phenomena. That's a famous perspective of Bohr, right? For this reason, an unambiguous description of quantum phenomena is required in principle to include all the relevant aspects of experimental arrangement. Now this is cool, because Bohr is saying, look, what we have discovered in quantum mechanics is when we see something, we're not just studying the system, we're studying the system and the thing which is interacting with together. Now why is this misleading? Because it's formulated in terms, measuring apparatus, experimental arrangement, it seems to be talking only what happened in a laboratory. Quantum mechanics, at his times, was only applied to things in laboratories, but today is applied to the star, the galaxy, the sun, which are not laboratories there. And we apply it there. We don't apply to measurement here or what happened there. We apply it to what happened there. So there should be a way to reformulate the same idea without having any reference to a laboratory and experimental apparatus. And there are many ways of doing that, but this is one. And this is, sorry for, see, Parvalisa to Compare. This is me, it's not Bohr. Whereas previously we thought that properties of every object could be determined even if we overlooked interaction occurring between the objects and anything else, which is interacted with, not an apparatus or a Ph.D. Quantum physics demonstrated that the interaction is inseparable from the phenomena. The ambiguous description of any phenomenon requires the inclusion of all the objects involved in the interaction which the phenomenon manifests itself. So in other words, only child at some point discovers that he's not the only the center of the universe, and there are other human beings like him. So there are other things like us in the universe. Like what? All. So here is the relation of quantum mechanics. This is the way I think there is a middle way, a possible middle way between these two extremes. To think that we don't need to start from specific observers. We just take any possible system and consider it an observer in the sense in which in quantum mechanics we talk about observers, or in the sense which is used in formulation of the theory. And every interaction, I should qualify with details, but that's not the place for doing this, is an interaction that counts as an observation in quantum mechanics. Of course, variables have no variable interaction, and what happened between interactions, this is the point, is nothing with respect to the system themselves, with respect to those systems. So how is it possible to do that? It's possible by going back to ask what a variable means. If we take a variable not as a characterization of what the system is, but a characterization of a manner of interaction between the system and something else, then of course variables don't need to have values when they're not interacting, because they, by their definition. And this opens the possibility that when a variable has a value, the fact that the variable has a value refers to the two systems interacting, and not to another system who is doing something else that is going to interact with both later on. So relational quantum mechanics is two ideas. First, that variables refer to manners of interaction between systems and not to the individual system. And second, that the value that the variable takes, so this is a position with respect to whoever is interacting by detecting the position, or whatever is interacting. There's no need to use, at this point, at this level, a personal characterization. So the main idea is in blue here. Physical systems describe how systems manifest themselves to other systems, and not how systems are. Right? And just to put it pictorially, since everybody sort of heard about the Schrödinger cat or the Wigner friend, just in a little comic thing here, in the Schrödinger cat, there is this situation in which the cat is in some sense a superposition of two states, meaning we don't see superposition, it's the effect of the superposition. Meaning that if we observe something and we want to compute what we observe, we go wrong if you assume that is one or the other. We have to, in our math, not to make this assumption. If you make the assumption, not that it is in one, but it's in either one of them, then we go wrong. So there is this precise sense in which, with respect to an observer who's doing calculations of quantum mechanics, the cat is in two different configurations, or more precisely, is in neither of the individual configurations. I cannot assume that it's in either one of them. But this doesn't forbid at all that with respect to the cat, the quantum system that sort of originated this superposition is in one or the other. We only have to disentangle the, we only have to not give any physical meaning to this probability here, which is a probability of what the girl is going to see, given that the cat is going to see something. So this is the relationality of relational quantum mechanics. Variables have a value with respect to a given system, and this is irrelevant for what another system is going to see in the future. It's relevant in the sense that you cannot make the calculation that given the probability of one of the two, the inside one, what's the probability of the other. All right, there's some technicalities here. I'm not going to. I want to leave room for discussion, so I'm going to close very fast here. I'm going to get to Nāgārjuna in a moment. But let me say one more thing about relational quantum mechanics. The last positive thing about relational quantum mechanics, then I'm going to throw doubt on relational quantum mechanics, which is the connection with information. Here, of course, the influence of John Wheeler was strong at the time. John sort of gave me pile and pile of all his notes on it forbidden and so on and so forth. People keep sending things to me, which I was very confused about. But obviously, if you take this view of the story, information suddenly becomes a natural language for thinking about it. And of course, later, quantum information and the interpretation of quantum mechanics had a huge evolution. This is in front of me. Why information is natural? Because if, remember, quantum mechanics is about making prediction. Some values you can predict others. So if two systems interact, imagine that you put yourself in the hat of one of the two systems. You can make prediction about the future given some past values that were realized with respect to you. So it's natural to think about this in terms of the information that one system has about the other system. And that's what the quantum state is from this perspective. So the quantum state of the wave function, depending on what one think it is nothing else that the information that the system has about another system is a coding of this information that allows it to make prediction about the future. And as such, it's sort of neither ontological nor epistemical. It's not epistemical because it's not about what one knows, it's facts. It's a coding of facts that happen. But it's not ontological because it's not something which is there. It's just a coding of a number of things that has happened between these two systems. And in particular, a system doesn't have a state because you need two states for it. If some of you are familiar with Everett, there are only relative states. There isn't the overall state. The only thing we need, and we can talk about, is useful to think about relative state. And then I realized at the time, and I was very happy, and this is what took me to write this paper in the 90s, that if you start with two postulates about information, you more or less, cheating a little bit and adding some continuity things, can reconstruct the mathematics of quantum mechanics, the non-commutativity, the Hilbert space, the projection, and so on and so forth. And these two postulates are these two. One that says that if you have a system, not an infinite system with a finite, classical finite phase space, the amount of information you can have about the system is finite. And the second is that even if you have the maximum amount of information, you can get more. Now, the two are not in contradiction because actually this is about relevant information. Relevant means the part which is information which is relevant for determining the probability of something else. So in other words, irrelevant is information you have about the system such that if you conditionalize with respect to it, nothing changes with respect to the probabilities. So what does this mean? It means that once you know everything there is to know about the system can still surprise you and give you change your information. Whoever knows quantum mechanics knows that very well. But when you do that, some of the previous information becomes irrelevant, which is exactly the erasing information aspect of quantum mechanics. And H bar is the quantity that determines the amount of information that is in the system, essentially is the revealed volume of its phase space divided by H bar, is a number. And also characterize this novelty, this infinite novelty. So you can get discreteness and probability out of that. I'm not talking about this because I don't want to use my time using more than what I thought. So let me go to the later time. I found this is fantastic. So why is not everybody jumping on relational quantum mechanics? This is it. This is after all, it has a lot of good aspects. It's realistic in the sense that it provides a story of what happens out there, right? Some sort of story in which we can locate ourselves as one of the ingredients and make sense of what is the perspective. It's a story which is a combination of perspectives more than a view from outside. It's just a narrative about how perspective can interact. One way of viewing relational quantum mechanics is Copenhagen quantum mechanics make democratic. Everybody has its own Copenhagen, and this is clearly so for those who are familiar with the Copenhagen. So it's realistic in the sense that it's an account of what happened in the world without needing to add neither agents or subject of experience, nor an ultimate reality from which to derive what you observe. There's nothing more than the deal with that. It merged very nicely with relativity, which not many interpretations do, certainly others do, certainly worlds do, QBism does. And it extends natural to quantum theory, to quantum gravity, which was the main reason for me to go there, because I need this way of thinking about quantum gravity. So why is not everybody jumping to it? Because it is a philosophical nightmare. No doubt. And that's what people are telling me. And I'm aware of that. Because if you go there, you're taking the ground under your philosophical view of the world in a strong sense. Which you like it if you're ex-hippie, but you definitely it makes things harder. Why? Because the description of physical system only exists with respect to another physical system. The variables of a physical system are only describe how it interacts with something else. So what is a physical system by itself? Well, nothing. Nothing remains. Okay? The reality of the physical system as a physical system, we're not doing philosophy, we're doing physics here. The reality as of a physical system, from a perspective of this physics, is not there. Unless I talk about our influence on the others. So how do I ground? What is the foundation of this whole picture here? And I was going around and talking about that and being immersed in that. And as some of our friends know here, every time I was talking publicly about that, there was somebody coming to me and saying and asking, "Have you read Nāgārjuna?" And it happened once, and it happened twice, it happened 3 times, it happened 10 times. And at some point, I could, and my answer was to connect to the introduction of both days. I don't believe this shit. Science and mysticism, Eastern mysticism. Come on, I was enthusiastic of the Tower of Physics when I was a kid. I read Alan Watts, I read all sorts of stuff, wonderful. But now I'm gonna, so but you know, have to read Nāgārjuna, how do you read Nāgārjuna? So I'm gonna read Nāgārjuna, okay? So I read Nāgārjuna. And first I looked at various translations, and then good friends said, well, look at the Garfield one, because that's what you're going to understand something about. So I had full immersions in that book. It was 2 years ago. And it was really full immersions. I mean, this book just conquered me. Monstruously conquered me. I mean, I just couldn't talk about anything else for the entire summer. My friends were sick and tired of me talking about that. So I really fell in love with it. And in a sense, I'm not... in a sense, I've already given my talk, so I'm now going to say something about the kind of ideas that come out for me from that book that helped me conceptually, philosophically, about thinking about quantum mechanics. But that will be very short, and because I've already put all the pieces there. So there are 2 ideas. So I have 2 slides with these 2 ideas. The first one is that there's nothing wrong in thinking about individual systems only in terms of how they affect or are affected by something else. Okay? In a sense, this is a law. But it's much stronger than that. Because Nāgārjuna doesn't just say that it's nothing wrong. He said that it's wrong if you don't do that. Which is much stronger. Precisely because we're talking about interactions. If you start by entities which have independent existence, we don't understand what is interaction later on, to put it in a very naive way. So this is the way, so as a physicist, I got there. And that's exactly, in a sense, what, so it's not it helped me to understand better quantum mechanics, but it helped me to, I was looking, I've always been fascinated in philosophy, I was looking constantly in the Western philosophical tradition for a perspective that was not idealism, was not phenomenology, was not materialism, was not this, was not that, was not that, was not a long list of things, to find one that I could use as a reference. And of course, there is a lot in Western philosophy about relationalism, there's Kant, there's everything, and there are ideas like that. Last night talking, came out even in Plato, which you can take as the most extreme of the other direction philosopher in the Sophista, there is a definition of being, which is to be is to interact, to be is to affect something else. So it's not that this kind of ideas are not existing in Western philosophy, but so clearly and cleanly understanding that you cannot think by systems by themselves, and therefore in the language you have to think about object and entities and empty. I find it extremely clarifying. And these are famous lines from the fantastic chapter 24, which is, I think, one of the core points, and I invite everybody to read Garfield commentary on it. If you perceive the existence of things in terms of their essence, so if you think they're logic, then this perception of all things will be without the perception of causes and conditions. So you miss exactly what you're looking for. You're looking for here as a physicist, not as a Buddhist thinking about the Buddhist causality, but it's probably exactly the same thing to me. Every cause and agent and action and condition arising and ceasing, in effect, will be readily possible. That's the first idea. But the second idea, which is the one that got much stronger into my mind, is the radical anti-foundationalism that goes with it. And that's what we did between. And that's what changed my way of thinking about things. These are the verses that follow immediately. Whatever is dependently co-arising, so when things exist in relation to one another, that is explained to be empty. So what we're talking about. And then that, being dependent designation itself in a way where that, as Jay says, can be referred to the entire two verses before. Let me put it this way. Let me go back to the first observation I made. Quantum mechanics is not about the elementary constituent of the world. That's something else. That's particle physics, whatever you want. Quantum mechanics is about systems. And a system is conventional. Like the system is an arbitrary carving of some of what we see around us, which we find it convenient to carve that way because it works to do some way. So not only the variables are not pertaining to the system itself, not only the values are not, but the system itself is completely conventional, right? So it is such by designation. You know, a chair is a chair because I call it a chair. And it goes back before Buddha. Object are not object by themselves. So what are we talking about when we talk about physics? We're talking just about this extremely conventional reality that we're using again. And what Nāgārjuna allows us to say is to take this and liberate the need of putting a fundamental, ultimate reality behind that, if not to the extent in which fundamental reality is awareness that this is the conventionality of conventional reality. That's what, I don't know if I understood anything of that correctly, but to me it had a fantastic, liberating effect reading that. So there's a sense in quantum mechanics itself conventional. We're not talking about what the world is, we're talking about how it makes sense of this world, and that's it. So let me read this comment here. For me this has been like coming out of a prison in which I've been, intellectual prison, I've been held for so long. I mean, there's something similar. Sometimes you read Wittgenstein, you have the same thing. Okay, I was asking wrong questions. And here the book demolishes, at least to me, the very idea that it's reasonable to search the single foundation on which to build the rest. And that sounds to me, a scientist sitting on top of centuries not related to Western science, as an extraordinary flash of wisdom. We have this immense knowledge about the world, which is fantastic, which is science. And the question is, all right, so what's the actual stuff we're talking about, the fundamental thing on which to build something? Just the wrong question. That's not what we're asking. So, thank you, Nāgārjuna.
Great, thank you. So we now will take questions from the other participants.
So one concern people have had about sort of relationist metaphysics is that, if you say that everything is relational and nothing that is non-relational in itself exists, then there's a puzzle about how the relations themselves could ever hold, because it seems like a relation requires relata. So, this is, of course, probably something you thought about, but I just wanted to put on the table a way of thinking about non-relational goings-on, which is nonetheless, I think, takes on board the idea that everything is essentially relational. Namely, to work backwards or backwards engineer to the essence of things, right, in themselves as dispositional, or essentially such as to stand that in certain conditions they would stand in certain relations. In these other conditions, they stand in other relations. And so they are really, in a way, one way to think about it is that they're a collection of potential relations. That would give you a way of, holding on to the intuitive idea of a relation as requiring relata, while still, honoring the idea that there's nothing that really, is over and above the relational essence of any given entity.
Yeah, thanks. Touch key things. I have two comments on this. I'm not going to answer. I'm just making two comments. One is that there's a beautiful dialogue between Einstein, already famous scientist, and Mach. At this point, old man. And of course, you know that Mach didn't believe in atoms. Okay? On the basis that there were useless ontological assumptions about ultimate reality that he didn't want because he only wanted to deal with them. And Einstein asked Mach, because Einstein was profoundly influenced by Mach, of course. I mean, in fact, he thanks Mach for liberating him from unnecessary metaphysical assumptions. But Einstein believed in atoms. In fact, Einstein is the one who demonstrated atoms, probably with the 95 paper of Brownian motion. So he asked Mach, look, Professor Mach, if I could use atoms, a way to organize my perceptions, this is the Machian language, would you be happy for me to use it? And Mach says, of course. Okay? What am I saying? That, of course, we make postulates about things that exist. But there's a difference in thinking then a la Mach, a very useful way of thinking, and somehow reading this activity as discovering the thing by itself. That's one comment. Just one comment, it's better. Otherwise, I take away time.
Could I follow up just very quickly? I mean, the suggestion though is just that there's a puzzle with respect to relationist metaphysics about what is it that is standing in these relations. So if you wanted to try to resolve that puzzle in a realistic way, you could go this way. You don't have to go Mach's way.
Yeah. I'm happy. I'm aware of that. I'm not an expert of Nāgārjuna at all, obviously. Just read books and everything. But also this came out in a conversation at breakfast, I think. I think that if Nāgārjuna came back and heard about structures, structural realism, he would say, well, this is fantastic, it's really nice, and he would add a chapter to his book saying structures are empty.
Excellent.
So they make sense.
Yeah.
It's not that they're non-existent, they're existent, but dependent
That's fine, then.
and codependent and conventional.
Thanks for the talk. I thought it was very clear, although my question may demonstrate that I don't really understand it. Could you say something more about a system? Because it seems systems themselves must be complex. If two systems are interacting, why do they not create one system? And you also mentioned that a system is conventional to begin with, so it's not clear why the relation between systems. I get confused. It may be, again, the same question. I'm confused about how you establish a relation between systems when this relationship itself seems to be conventional. You could easily consider it to be a single system once the two systems are interacting with one another.
You do. You do. We constantly do that. We constantly do that, and look at this version of what is happening. There is a quantum system here and there is an observer. Okay? So we make sense that if I was observer, this is what I would see. Right? And this quantum system is that. Okay? But the touch and the observer and the system can be considered as systems, a quantum system together. And as such, we are describing how the two together affect entering relation with the others. So what the theory is about, it's the relation to all the perspectives that any part of the world can have.
Yeah, I guess my concern is a Wigner's friend kind of argument is at some point the actual determination of the state, even though it's relative to a particular observer, that observer must have one foot outside the system. That's
Observer
my
always
sense.
has both foot outside the system. Observer is outside the system. So the what really the chapter, the last chapter, is not of the appendix of what I say, the epilogue of there is no contradiction between the two pictures. So that's what I'm trying to stress. The two pictures are apparently contradictory if you take them as sort of seen from the outside and both true. The two pictures being the story relative to one observer and the story relative to the other observer. Given any specific use of quantum mechanics or perception of reality or part of the description of reality, it's always relative to something. So that something is outside the description. That idea is classical maybe what you and I part is that something doesn't need to have the full complexity of the structure that a human being has to have. Any part of the world can play the role of what is affected by another way.
Well, I just want to say, that was great talk, and also that just speaking to the, for those of us sort of in the meeting, that this was archetypal, right? This is kind of what we're trying to do. This is a great example of not doing what happened with the Tao of physics. It's that the philosophies that emerged from classical India and Asia may offer. They're just a new set of ideas, or a set of ideas that weren't articulated in the same way, or as fully as in the Western stream. That there may be entirely new ways of encountering these certain ideas that weren't in the Western stream. And so that's what we're trying to do here. We're trying to see whether or not there's, questions in physics might benefit from this entire other civilizations, multiple civilizations approach to these questions. So I thought that was great. It was a great way to get started. But I do have a question. So when you talk about, I'm going to add two to it. One is a question and then just a comment. When you say anti-foundationalism, for you, what does that mean? You talk about that this was enormously anti-foundationalist.
Yeah, I went fast there. Well, I mean a number of things. I mean that a number of questions that we try to pose in talking about that are probably not useful questions, not interesting questions. Like,
What is give me some examples of that?
Well, what's the ultimate stuff out of all this emerge? That's not a good question.
Right. Some stuff that stands in and of itself that has independent being is the basal structure.
Yeah. I mean, there's one way of reading, and this is probably flattening too much, but there's one way of reading, and I'm aware of possible levels different which can be read, what Nāgārjuna says about conventional and ultimate reality. Mm-hmm. And one way of reading is that you start from this distinction, and you also start with this distinction in science, in a sense, right? I mean, this is it's conventional reality, but then there are atoms, and that's more. But of course, in science, you understand that atoms themselves are, modes of the quantum field theory to interact with other impact. So one way of reading what Nāgārjuna says is that the ultimate reality is not a reality which is there to reach us. It's in a sense, it's not there, or it is just a realization that conventional reality is conventional, and that's fantastic because it allows you to do science, liberating yourself from the need to ask certain kind of questions. Where's the ground of the existing things by itself, out of which all the rest comes out? That might be the wrong question. That's, as a scientist, the pieces of tools of this thinking that I'm making mine. So
the last thing I just want to say, because I'm something for discussion, especially for among the Buddhist scholars. You sort of said, like, in this description, well, with this, we don't need to add agents, right? We don't need to add vague agents. And I just want to say, from kind of the perspective that, like, Evan and Marcelo are saying, we'd say it's not that you add agents, you begin with agency. Like, that's really all physics, all science always starts with agencies doing it. And so, in some sense, it's not, you can't escape agents and agency in some sense. So that's the place to build. But I'm not adding, this is, I think, pertinent to the discussion. Yeah. Other questions? Yes?
I'm not at all a physicist and barely a Buddhist, but this may be very, very naive. Does this formulation essentially turn the Big Bang into Schrödinger's cat? Because it's both?
Yes, a strong way of putting it. A little bit yes, in the sense that sort of consensus that first we haven't understood what happened at the Big Bang. We don't know. So it might be the beginning of time or might not. So it's really open scientifically as a question. But there is a large consensus that is a quantum phenomenon that is relevant to what happened there. So being a quantum phenomenon, it's affected by probability and by the kind of questions that quantum mechanics open. So in some sense, you're right, but I wouldn't overplay this.
Just a quick follow-up on this. Is it significant, I love this diagram, I think it's fantastic, but is it significant to you that the cat and the little girl are both, they're particular kinds of systems, we would call them sentient creatures?
Ah, that's a key point. The answer is no. But this is maybe for you, but not for me. The way to put it is that the kind of things that happen at the physical level, which is described here, if in addition, the systems here has senses and memories, stores the information besides just and a neuron and a complex brain that make calculation, and in addition has developed language and talk with his girlfriends, and in addition is in a culture and has studied Descartes and Kant and read Nāgārjuna, then it's all that. And at each stage you add something about the complexity of what happens to her. But my opinion, and is where I'm maybe distant from some of the people here, it's my opinion is that part of the story requires neuroscience, social theory, history of culture. But underlying all this, a deep relationality which is purely physical that demolishes the idea that there is a pure third-person description of the world. Because physics is only first person. It's only talking about how to think. And I think I learned from neuroscience, and maybe from Buddhism also, that the mind itself is not a thing either. So therefore, this huge duality, which you wrote, it's losing ground on both sides. That's what it seems to me.
Okay, we have time for one more short question.
So just to follow up on that, then you would say that, a rock can also enter into these kinds of relations.
Yeah.
And so, but a rock is not an epistemic agent in the way Adam, right? It is not.
It's not.
So epistemic agency is not relevant to this model.
Right.
Okay.
Right. Of course, if you understand what we specifically do, you have to write the stuff.
Right.
Okay. So we specifically do predictions, but to do predictions, this, we have to have memory to get things to do that. But that's because we are more than. And that's the way I view this.
Okay, thank you very much. That was a great talk. So now we switch from physicists talking to Buddhist scholars.
While Sanjot is setting me up, let me just take a moment to thank Bob and Sanjot and everybody else for involving me in this tawdry affair, and to say that I'm happy to suffer the scorn that seems to be appropriate for all of us. But I also want to thank Carlo for just an absolutely dazzling talk, a fellow Pittsburgher, which is really nice.
But it was just really nice to see these ideas from Nāgārjuna working their ways into physics. I've admired Carlo's work for so many years, and I was quite frankly kind of starstruck knowing that I was going to meet him this week and a little bit scared. But it's really nice finally to meet you and to engage like this. There. And I think that Carlo's talk gave us a really beautiful illustration of how all of those three dimensions of dependent origination play into quantum mechanics. And so that's just an advertisement for Chandrakirti, who I like a lot. So my talk is called Can't Find the Time, and it's about temporality in Madhyamaka. And I'm sorry that it's not the same title that there was in the program. At some point, I probably forgot to send the change of title to Bob, or else Bob lost the email, or something like that. But there was a time when I thought I was going to do a lot more than I was going to do. And then I discovered I was going to do exactly as much as I was going to do. So, with all of that, I'm neither a physicist nor a philosopher of time. I'm also going to apologize. I'm going to read this. That'll keep me on time. Now I'm already going over time, right? So I'm not a physicist or a philosopher of time. So I can't say to what degree the ideas that I explore here are going to be relevant to the physics of time or to contemporary philosophy of time. This will be all about time. I suspect that they have very little of value to say to contemporary physics or to the philosophers who work on its margins. But my aim here is to sketch the 2nd century Indian philosopher Nāgārjuna's understanding of the nature of time, and to explore the ways that his account is taken up by Tsongkhapa in the 14th century Tibet and by Dogen in 13th century Japan. If there's going to be meaningful dialogue between the classical and medieval Buddhist tradition and contemporary science, I think we need to get both sides of that dialogue right. That is, dialogue gets going when each side really understands each other. So I take it to be my job in this conference to do the really nasty antiquarian work and just to sort of nail that stuff down, even if in the end it forces us to lower our expectations regarding the outcome of dialogue. Nāgārjuna addresses time most directly in chapter 19 of Mula Madhyamaka Karika, but that discussion already trades on his analysis of motion in chapter 2, and to some extent on his analysis of arising and cessation in chapter 7. And for that reason, we're going to approach chapter 19 in that direct discussion of time through chapter 2. But before that, I want to make a few remarks about Nāgārjuna's broader philosophical project as it's articulated in the Prasangika Madhyamaka tradition in order to provide some context for the discussion of time itself. So now we're going to talk broad framework. That's what Nāgārjuna looked like. Okay. So once Nāgārjuna's account is on the table, we can turn to Tsongkhapa's commentary and then to some of Dogen's remarks on time, because I like to treat Dogen as a kind of honorary Geluk. We're going to see that while Tsongkhapa and Dogen are each walking in Nāgārjuna's footsteps, they pause at important points on that path to develop implications of this itinerary that exceed those that Nāgārjuna himself explored. That's how commentary works. The Prasangika Madhyamaka tradition, like any philosophical tradition, is progressive, and it's really useful in order to understand even the originary ideas, to explore the trajectory of thought they inspired. And that's just, again, the essence of a scholastic or commentarial tradition, that you want to look at the history of a text, not just the text itself. My remarks are going to be confined to that tradition of Madhyamaka thought, a tradition in which I perhaps tendentiously include Dogen, despite the fact that he's not historically connected to the Svatantrika Prasangika debates that give rise to the doxographic categories that I'm working with, and which are distinctively Tibetan approaches to the history of Indian Buddhist philosophy. I think Dogen's philosophical outlook is close enough to that of Chandrakirti, as it's understood by Tsongkhapa, that he could be considered an honorary Prasangika. So I'm going to conclude with a few pessimistic speculations on dialogue between Buddhism and modern physics. Carlo's job is to do all the optimistic speculation, and that's partly because he's talking about quantum mechanics, but I'm talking about time, and I think it gets a little more pessimistic when we get to time. But we'll see. So I'm going to begin with this broad framework of Prasangika Madhyamaka philosophy. This is going to be quick, as I assume that most people here know this stuff. For those who don't, a really quick sketch is going to have to suffice because we can't do a whole intro to Madhyamaka thing. Okay. Nāgārjuna's big idea is that all phenomena, whether the macroscopic contents of the phenomenal world or the evanescent dharmas to which the abhidharmakas take them to reduce, or we might say systems of people and tables and chairs or systems of subatomic particles, if you want, are empty of any intrinsic identity. To exist intrinsically in the sense Nāgārjuna rejects is to exist independently, to have an essence or to be fundamental or foundational. It's important to this framework that it's intrinsic existence, not existence itself, that is the object of negation in Madhyamaka analysis. Nāgārjuna and his followers are not denying the reality either of the macroscopic world or of any unobservable entities that underlie that reality. To the contrary, they accept that reality. Instead, they deny that to be real is to be intrinsically real. And they argue that the only mode of reality that makes any sense is conventional reality. To be conventionally real is to exist in an everyday, unexamined sense. To depend for ontological status on practices and agreement, and those would include scientific practices and scientific agreement. Thank you. To be nominally real. That is, to be real is not to be independent, foundational, or to have an essence. Instead, it's to be dependently originated. Dependent origination, in turn, is glossed by Chandrakirti in three ways, and here's the connection to Carlo's talk. Causal interdependence, mereological interdependence, and imputational interdependence. That is, real things are part of the causal nexus of the universe. They depend upon causes and conditions, and themselves have effects. Real things depend for their existence on their parts, as well as upon the wholes in which they figure. It's important to see the mereological dependence is symmetrical in that respect. Real things are identified as things or as systems in virtue of the explanatory interests and practices of those who identify them. Ontology is determined by explanation. This is the sense in which Madhyamaka philosophy takes itself to be the middle way, and I think very consistent with what Carlo said a few minutes ago. It avoids the extreme of reification by not treating entities as existing intrinsically. It avoids the extreme of nihilism by taking their conventional existence seriously as actuality. Moreover, as Chandrakirti and Tsongkhapa emphasize, to take the conventional seriously is to treat it as a truth, as reality, and to draw a robust distinction between truth and falsehood within the convention. A distinction we draw through the deployment of our epistemic resources, including perception, inference, testimony, analogy, science, whatever you want. When we take the measure of reality to determine what's true and what's false, everything we measure and every judgment about truth and falsity occurs within the domain of the conventional. One way to put that is to take Carlo's metaphor again, and especially in his response to Bob. What you don't find is, it makes sense to talk about what a system looks like relative to an observer, or what a system looks like relative to another system. But then if you step back and ask, what does that look like independent of any observer and independent of any system? You're kind of like asking, what's the last natural number, right? It's just a sentence, it just doesn't get any meaning. This robust realism is the flip side of a global illusionism. While Madhyamikas agree with those in other Buddhist traditions that conventional reality is illusory, illusion is, as it always is in classical Indian philosophy, glossed not as the appearance of that which is non-existent, but as the discordance between a mode of existence and a mode of appearance. It's something appearing in a way other than the way that it exists. In particular, the global illusion to be overcome in Madhyamaka philosophy is not the illusion that the world is real despite its unreality, but instead the illusion that the world is populated by intrinsically real phenomena, when it's in fact populated by dependently originated phenomena. I think that's really, really important to hold in mind. People hear that word illusion and they think, oh my God, it's an absolute idealism. All of Madhyamaka is devoted to drawing our attention to this illusion, to explaining this illusion, and to extirpating this illusion. That is so with respect to time, no less than with other objects of Madhyamaka analysis. So much for the fast introduction to Madhyamaka for those unfamiliar, and so much for an attempt to direct the attention of those who are familiar with Madhyamaka to the aspects of the philosophical system that will be important to me in what follows. We're now going to turn to Nāgārjuna's analysis of motion in chapter 2 of the fundamental verses. Okay. Chapter 2 is a really hard read, I have to say. And it's been the subject of a good deal of dispute, both in canonical literature and in modern commentarial literature. You get a lot of interpretations of this chapter that are wildly different from one another. The nice thing is that today you'll get the accurate, true interpretation that supersedes all of the others, okay? John will probably fight with me about this, but that's okay. He's used to being wrong. Okay. Some of what I say will involve taking sides in some of these disputes. And whenever this is the case, I will now confess, I'm going to take the side of Chandrakirti and Tsongkhapa. That is, I'm going to see Nāgārjuna's project, as I've explained, as a critique of intrinsic reality that never extends to a denial of reality of the conventional world or of the importance of conventional truth. As a critique that takes the deep identity of conventional and ultimate for granted. Oh, we're not going to go there yet, sorry. As Tsongkhapa puts this point nicely when he says, here's the Tsongkhapa, the refutation of coming and going should be understood as the refutation of coming and going as the nature of the object of uncontaminated wisdom. Since the goer and the action of going exist in mutual dependence, that is, they do exist in mutual dependence, but do not exist inherently, the inherent existence of coming and going is the object of negation. These are words you can write in lipstick on your mirror in the morning, and just read them every morning, and this will really help you come to grips with ontology. There are two important reasons to read this chapter, chapter 2. This is Tsongkhapa's conclusion of his commentary on chapter 2. In the context for the later chapter on time itself. First, the discussion of motion is really intended as a special case of the discussion of change in general. It's not just motion. And of the relations among past, present, and future. It's hence already an initial exploration of temporality. Second, the pattern of argument established in this chapter is assumed in chapter 19, and that chapter only makes sense if this chapter is borne in mind. And Chandrakirti and Tsongkhapa each say this repeatedly in the commentary, right? The pattern of explanation here is the one established in the examination of motion, and it just runs through the whole thing. So it's not just a hard chapter, but it's an important one. Chapter 2 comprises several arguments, each intending to show that while we can make sense of motion and hence of change in the context of interdependence, we can make no sense of motion or change in the context of intrinsic existence. That is, while it makes perfect sense to take motion and change for granted conventionally, it makes no sense whatsoever to take them as ultimately real. They are empty of that kind of reality. Two of these arguments are relevant to Nāgārjuna's treatment of time. The first argument, reminiscent of Zeno of Elia's era paradox, presented in verse 1, let's see, we should have verse 1 there, yeah, okay, asks where motion occurs. Is it in the part of the path over which one's already gone, in the part of the path over which one is yet to go, or where one is in the present moment? Oh boy, the first two are in the past and the future respectively, and so no motion is occurring there now. The present is an instant, and so there's no time to go anywhere. So motion can't be located anywhere. As Chandrakirti and Tsongkhapa argue, this is not an argument against the reality of motion, as say Zeno takes it to be, but rather against the cogency of thinking of motion as an entity located at a specific place, as a thing. Instead, Nāgārjuna argues we should think of motion as a set of relations. Relations between where a thing is at one time and where it is at another, not as an entity present at one place or another. Its mode of existence is thus interdependent, not independent. It's empty of any reality of its own, despite being actual. This forms part of the template for Nāgārjuna's thinking about time. The second argument in verses let's see, sorry about that, 5 through 11, is a regress argument. If motion is a property of the mover, Nāgārjuna argues, then as the mover moves, no, we don't want that, okay. As the mover moves, the mover's motion's got to move as well, or it's going to be left behind, right? So as I'm moving, if motion is my property, it had better move with me, or I'm going to leave it back over there when I get over here, and that would be pretty strange. Okay, if the motion moves, though, it's got to move on the essentialist view in virtue of yet another motion, which again has got to move with the motion or get left behind. And that motion requires yet another and so forth. The regress suggests to Nāgārjuna again that the possession of the property of motion can't be the explanation of moving. Instead, once again, Nāgārjuna concludes not that there is no motion or change in the world, but that motion can only be thought of as a relation between a thing being in one place at one time and at another place in another time. No further property or thing called motion is needed. A bit of reflection is going to convince you that there's a nice anticipation of MacTaggart here. Anticipations that we're going to see are more explicit in chapter 19. And it's to that chapter that we finally turn. Let's see, that's the Tsongkhapa comment on that, which we're not going to talk about. So, we've seen that in his examination of motion and change, by the way, that's Tsongkhapa now, because we're going to be heading towards Tsongkhapa pretty soon. Nāgārjuna is concerned not to refute the reality of motion, but to argue that it has no independent existence, that exists only as a set of relations. We'll see that his project with regard to time is precisely analogous. And we've seen that Nāgārjuna's strategy in the case of motion is to argue first that motion can't exist in the past, present, or future, and second, to take motion to be an independent entity would lead to a vicious regress. Those are the two important arguments. We'll see the same two strategies adopted in his discussion of time. There's one dialectical difference between chapter 2 and chapter 19, however. Because of the long tradition of speculation about time in Indian philosophy, and because of the particular Sarvastivādan position that informs so much of the Abhidharma literature towards which Nāgārjuna's critique is aimed, we do find particular Purvapakshas, or particular opponents, represented in this chapter. And that dialectical context helps to sharpen some of the arguments. Here we're not going to consider each of the opponents Nāgārjuna considers, but we're going to address the Sarvastivādan position, given its importance in his project. The important doctrine of the Sarvastivāda for this chapter was first the thesis that past, present, and all phenomena, past, present, and future, as well as those temporal periods themselves, the past, the present, and the future, exist, and that the phenomena of the present are distinguished from those in the past and future only in that they alone have causal efficacy, conceived as a mode of existence. So the Sarvastivādans think past, present, and future stuff, it all exists. The only difference that distinguishes the present is its mode of existence, and that is that it's existing, it's causally efficacious right now. Nāgārjuna is going to be concerned to show that this is incoherent, given the inextricability of existence from causal efficacy. You can't have one without the other. And in virtue of the distinction drawn between the past, present, and future, and between past, present, and future events. So Nāgārjuna, we're going to just keep talking this one. Nāgārjuna begins the analysis with a destructive dilemma expressed in verses 1 through 3. He says if the present and the future depended on the past, then the present and the future would have to have existed in the past. If the present and the future don't exist there, how could the present and the future be dependent on it? Without depending on the past, though, neither of the two could be established. Therefore, neither present nor future would exist. So, let's begin by getting the target of Nāgārjuna's critique in view. Following Tsongkhapa's admonition that you can't understand a Prasangika argument without first clearly identifying the object of negation, the target is a natural attitude turned into philosophical theory in slightly different ways in the hands of Nyaya Vaisheshika and Vaibhashika and the Vaibhashika schools of Sarvastivāda. It's natural, perfectly natural for us, to think of time as a kind of pre-existing container into which events are found at different locations. So a kind of infinite given expanse, as Kant says. And you've just got events scattered through it. It's kind of natural to think of it that way. To think of time this way is to think of it as existing independently, with some of its parts located in the past, some in the future, and one of them in the present. It's to identify temporal locations as determinate points on an antecedently existent continuum, and the temporal locations of events as accidental properties of those events, just reflecting where they happen to have landed in that vast container. On this view, it makes sense both to think of time and its parts as intrinsically existent entities, and to think of all parts of time and the events occurring in those parts as coexistent in some trans-temporal sense. That position, which I think is a pretty nice recap of the Sarvastivadin account, is no straw man. First, it's the way that most of us understand time intuitively. And it's just easy to get that intuition. And when students read Kant and they say time is an infinite given magnitude, they say, yeah, of course, right? So it's really natural to think of it that way. A vast container of reality stretching into the past, at least until the Big Bang, and into an indefinite future, with the history of the universe filling that primordial container. Secondly, plenty of philosophy, European and Indian, ramifies this intuition into systematic metaphysics. Newton and Kant each argued that time should be understood this way, Newton adding the metaphor of flow to indicate its anisotropy, and Kant arguing that time is an a priori intuition of an infinite given magnitude. And more pertinent to Nāgārjuna's context, orthodox Indian philosophers, such as Nyāyakas, and influential Buddhist philosophers, such as Vaibhashikas, defended its reality as an independent, pre-existent container for events. Nāgārjuna argues that this intuitive view and its theoretical elaborations are simply incoherent. Let's now unpack the argument at the beginning of chapter 19. Nāgārjuna's implicit premise is that if the three temporal periods exist as entities, they've got to either be mutually dependent or mutually independent. They can't be mutually dependent because if, say, the present and the future were dependent on the past, they would have had to have existed in the past. Mutatis mutandis if the present and past were dependent on the future. This argument trades on the assumption that temporal periods are entities, and so that time itself is to be thought of as an entity. For entities to stand in dependence relations, he presumes, they've got to be co-present, since for one thing to depend on another, when the second exists, the first has got to as well. But nor can they be independent, for the very definitions of past, present, and future involve mutual dependence. As Tsongkhapa puts it, no, we're not going to have that. After obtaining its identity, the present of a thing, such a thing as a sprout, has got to be posited as that which is not shed or passed beyond that status. This would be inconsistent with the present not depending on the past. For something to count as past, it's got to precede the present. For it to count as future, it's got to succeed the present. Thus, there's an inescapable dependence of the past on the present. So Nāgārjuna concludes, since any entities must be either mutually dependent or mutually independent, and since distinct temporal periods can be neither mutually dependent nor independent, temporal periods must not be entities. Once again, this isn't meant to be an argument against the reality of past, present, and future, but rather an argument against their intrinsic reality, or their existence as entities prior to and independent of the events that we represent as past, present, and future. The conclusion of the argument is that we can only understand these temporal periods, and hence time itself, as a system of relations, not as a system of things. The kind of dependence that obtains between past, present, and future is the interdependence of events that are past, present, or future in relation to us, not the dependence between periods themselves. This analysis is hence directly parallel to the first argument against motion, in which we discovered that motion can't be located in the past, present, and future, but can only be understood as a set of relations, of positions of a moving object at distinct times. And this takes us directly to the beautiful argument at 19.5, where Nāgārjuna says, a non-enduring time is not grasped. Nothing one could grasp as time could exist as enduring. If time isn't grasped, how is it known? This argument is parallel to the second of the arguments concerning motion we considered, the regress argument. Once again, it's framed as a destructive dilemma. If time is an entity, it's got to either endure or be momentary. And Nāgārjuna claims that neither option makes any sense. There are two ways to complete the argument. Here's the most straightforward way to put it. If time itself were momentary, we could make no sense of temporal relations. For one thing to be earlier or later than another, as Kant was to point out a millennium and a half later, they've got to each be located at different points in the same time. Time, as Kant put it, has got to be that infinite given magnitude, or a pure intuition that is a single thing. And different times, as he points out, are at different locations in the same time. And otherwise, you can't make sense of temporal relations. Time can't endure as an entity, since if it did, the past would continue to be present, and it's of the essence of time that it passes. But we can generalize the argument following the pattern of Chapter 2, giving us a richer sense of what Nāgārjuna has in mind. And I think this is the real import of the argument in Chapter 19. Each horn of the dilemma implicates a regress argument. Why can't time be momentary? Because if time existed at some time and not at others, there'd have to be a background super time against which it flows, and we're off on a vicious regress again. But if time were to endure as a permanent entity, it would have to exist at all times. And once again, we need a super time, each of whose moments times exists, and we've got the same regress. So just as we got that regress argument in the second argument in Chapter 2, we get the same regress argument in Chapter 19. So just as taking motion to be an entity required us to posit another motion by means of which it moves to keep up with the mover, taking time to be an entity forces us to posit another time in which it either endures or fails to endure. As Tsongkhapa emphasizes, closely following Chandrakirti's commentaries on the fundamental verses and on Aryadeva's 400 verses, just as the arguments presented in Chapter 2 do not undermine the conventional reality of motion, but only its existence as an independent entity, the arguments in Chapter 19 do not undermine the conventional existence of time, but only its existence as an independent entity. Time is a system of relations between events, nothing more than that. Tsongkhapa sums it up beautifully this way. I'm going to read you a little bit of Tsongkhapa. That temporal period on the basis of which that which is yet to come to it, that is the future, and that which is passed from it, the past, are posited, is called the present. Therefore, the present is the most important temporal period. I think this is a really nice insight of Tsongkhapa's. The future is that which is not yet arisen, although it has a cause. The past is also said to be that which has come into existence and then ceased. The present is the temporal period in which such things as a sprout can have arisen but have not yet ceased. At that time, while its cause has ceased, the effect hasn't yet ceased. So the disintegrated sprout is the past state of that sprout. I mean, we could go further, but we're going to get back to that disintegration idea in a moment because it's very, very cool, and it's Tsongkhapa's really signal contribution to this. There's a few things worth noting about Tsongkhapa's remarks, though. The first is the special role of the present in establishing temporal relations. Time, Tsongkhapa emphasizes, comprises no privileged moments. But we as observers or measurers of time, and you know that word that we get in Indian epistemology, pramana, it's an epistemic instrument, really means to measure. And so I'm constantly using that word measure, because that's the sense of knowledge that's relevant to Nāgārjuna, relevant to Chandrakirti, relevant to Tsongkhapa. We know things when we take their measure or measure them. And that's, again, a really deep connection between Nāgārjuna's perspective and quantum theory, I think. What is future? It's future only in relation to that present where we're measuring time, not absolute. And what is past is what is disintegrated at that present, nothing that's absolutely past. And this is why the present, the moment from which time is measured, is so important. It establishes where the observer is. Secondly, and this is an idea that runs through Tsongkhapa's exposition of Prasangika Madhyamaka, one that he lists among the 8 special points of this system. Disintegration, the Tibetan is Shikpa or Vinasha in Sanskrit, plays a critical role in establishing the relation between past, present, and future, and so in determining the direction or anisotropy of time. And it's this topic that we now turn. And I think this gets kind of interesting at this point when we start thinking about anisotropy. In his commentary on Chapter 19 of Mula Madhyamaka, and more extensively in his commentary on Chapter 7, and this is where it really gets drawn out in gory detail, Tsongkhapa emphasizes the role of disintegration as a functional entity in the Prasangika understanding of the structure of causality and time. Disintegration, he argues, has got to count as a real phenomenon if we're going to account for the structure of dependent origination. This is because causes are no longer around when their effects arise, and so can't be said to condition them or be the things on which they directly depend. But the disintegration of the cause, its having passed out of existence, is still around, if only as an implicative negation. And so can be that on which the arising of an effect depends. This is the core of Tsongkhapa's understanding of Nāgārjuna's response to the Sarvastivadin account of the causal, boy, how many genitives in one sentence, of the causal process. Instead of positing the continued reality, I think I've been reading Tsongkhapa too much actually, the continued reality of the cause as past in order to account for its efficacy, Tsongkhapa assigns the efficacy to the disintegration of the cause, something that continues to exist, albeit as a negation in the present. This device, originally introduced to make sense of dependent origination, also enables what we might call Tsongkhapa's weak presentism as an alternative to Sarvastivadin's strong realism about the past and the future. While Tsongkhapa agrees that past, present, and future each exist conventionally, he does want, as we've seen, to assign an ontological pride of place to the present as that where we stand, where reality is actualized, and from which it is measured. The past and the future, we've seen him argue, are always only the past and future with respect to a particular present, even though that present can only be understood as a boundary between that past and future. That's, again, the kind of two-way dependence here. That's why he's a presentist in a sense, but only in a weak sense. While he acknowledges the present as the most important of the three temporal periods, it's just as dependent on past and future as they are on it. They, however, are dependent as what once existed and what will exist, while the present exists, in fact. Once again, though, this difference is not as ontologically loaded as it sounds. We might compare it to the difference between here and there. What's here is prior in one important sense to what's there. I can only speak from here. But that doesn't mean that I can't speak from other places as well. I just have to go to them. It's just that wherever I am, that place turns out to be here. That's how indexicality works in Deixis. Wherever I am, the case is the same for the present. Whenever I am, I'm always now. But that doesn't mean that this now is privileged in time. Every moment is a now, just as every place is a here. This device has an added benefit in Tsongkhapa's system, though. It allows him to account for the anisotropy of time. The past, as he points out, is what has disintegrated, and disintegration is a one-way street. I find it interesting to note that Tsongkhapa does not say that everything in the past has disintegrated, or that what lies in the future or the future has yet to disintegrate. Instead, he says that what has disintegrated is the past, that what has arisen and what has yet to disintegrate is the present, and that what has yet to arise is the future. That is, Tsongkhapa doesn't begin with a prior understanding of temporality and then locate the process of dependent origination in time. Instead, he begins with an understanding of dependent origination and then defined temporal periods in terms of dependent origination. I think that's the great genius of Tsongkhapa in this commentary on chapter 19. It's not there in Nāgārjuna, literally, but Tsongkhapa draws that implication out very, very beautifully. It is the disintegrated seed that is the past, the yet to be disintegrated sprout that is present, and the yet to arise rice seedling that is future. To put this in a different way, events do not occur in time. Instead, time is actualized in the occurrence of and the relations between events. For this reason, while I'm a bit leery of the claims that classical and medieval Indian and Tibetan Madhyamikas scooped Max Planck and Albert Einstein, I do think that there is something in the idea that Tsongkhapa, in his exposition of Nāgārjuna's idea, scoops Ludwig Boltzmann, where Boltzmann argued that the anisotropy of time could be established through the statistical mechanical interpretation of the second law of thermodynamics. He did not claim that thermodynamic systems always evolve towards disorder and disintegration in the direction of the past to the future. He argued that we can define the direction of time in terms of the increase of entropy. And that was Boltzmann's insight, and I think that's Tsongkhapa's insight too, in a really weird way. Now, Tsongkhapa, however omniscient his Geluk followers take him to have been, knew nothing of thermodynamics or its reduction to statistical mechanics. He didn't scoop Boltzmann in that sense, any more than Nāgārjuna scooped Planck or Einstein. But he shared an important intuition with Boltzmann, an idea that he drew from Nāgārjuna's terse analysis of time and temporality. It's not just that time is not a prior thing or a container of events, but a structure of relations among events. The deeper point is that the structure of time, the set of relations that constitutes temporality, depends upon the events that instantiate those relations. And the anisotropy of decay, a central aspect of impermanence, plays the same role in Tsongkhapa's analysis of time that the anisotropy of entropy plays in Boltzmann's analysis. Tsongkhapa's emphasis on the distinctive role that disintegration plays in the Prasangika system is hence of the first importance, and one of the many ways that, many reasons that I've got so much admiration for Tsongkhapa as a philosopher. Now we're going to turn to Dogen. The section's called Being as Time, Dogen on the two aspects of temporality. It's hard to talk about Madhyamaka Buddhist analyses of time without attention to Dogen. While his own essays on this topic are less directly commentarial than are those we find in Tibetan Madhyamaka literature, it's clear he's also mining the vein that Nāgārjuna first opened when he connected time and being in Uji, an essay the title of which could be translated variously as Being Time, For the Time Being, Once Upon a Time. You can riff on that a lot of different ways, and Bob is a gold mine of different ways to translate that title. In this essay, Dogen explores the deep identity between time and dependent origination, and reinforces the idea that just as we can only understand existence as existence in time, we can only understand time as the mutual temporality of existence. Dogen, however, to a greater degree than Tsongkhapa, emphasizes the role of observation and measurement in our sense of time, integrating the metaphysics of time with the phenomenology of time. While this rich essay deserves a really careful line-by-line gloss, that would take the rest of the conference, we're going to have to content ourselves with a few highlights. And I'm following the Tanahashi translation because I really like it. And so this is the first place we're going to be looking. I'm not going to read the quotations to you. I'm just going to put them up there. Dogen begins by centering the observer in the interest of unifying an account of experienced time with an account of time itself. Just as Tsongkhapa emphasizes the identity of time with temporally related phenomena, Dogen emphasizes that we don't stand outside of time to contemplate it, but ourselves constitute time in the same way that other dependently originated entities do. And that's partly Carlo's response to John. Rocks instantiate time, we instantiate time, and we both instantiate them by interacting causally with what's around us. And the fact that we're aware of our interactions and rocks aren't plays very little role in this whole affair. Okay, Dogen, I just said that. Dogen emphasizes we don't stand outside of time to contemplate it, but ourselves constitute time in the same way that other entities do. We don't live through time. We, along with the entire world, actualize time. Each of our successive moments of awareness and existence is a moment, only in virtue of its relation to other moments and to other events, not because its existence is an independent temporal locus. Our experience of ourselves as subjects, and hence the experience of any objects, is only possible to the extent that our subjectivity, as he puts it, sets itself out in array, that is experienced as temporally ordered. And that order is induced by interdependence, and hence by the direction of disintegration. And Dogen contrasts that with his more naive experience of temporality. This is what he's going after. We do seem inexorably drawn to the vision of time as a pre-existent vessel. It just seems almost to be wired into our consciousness, and as I said, ramified in really bad philosophy. As something we cross, like a river or a mountain, in which we experience change and from which we are therefore distinct. We then fail to experience our own existence as thoroughly temporal, as constituting the time we experience, just as we fail to experience time as entirely interdependent with our own existence and that of everything else. Dogen replies to this naive view in this way. He says it's not that simple. Even the analogy of crossing mountains and rivers fails on its own terms. Crossing mountains and rivers requires our co-presence with those mountains and rivers. You can't cross a mountain that you're not co-present with, and you can't cross a river with which you're not co-present. It's already a temporally laden process. So to take the mountains and rivers we cross as an analogy for an independent expanse of time that we traverse in our lives doesn't get the distinction between ourselves and time that we seek. We, the mountains, the rivers, the crossing, are not co-present in an independent temporal order. They are already temporally constituted. And more to the point, we don't pass through time as we age. The sequence of the moments of our lives, powered by the impermanence expressed as disintegration, constitute the time of our lives. Again, emphasizes the two interconnected aspects of time. Its apparent flow, or as he puts it, flying away, and its omnipresence as a structure connecting all events. Here, perhaps, we'd see premonitions both of Hermann Minkowski and James McTaggart. Dogen emphasizes that although the experience of time as flowing or as flying away might be our most salient experience of time, that's only one aspect. That's its anisotropy. The other aspect is its complete imbrication with all of existence as the set of temporal relations in which all events stand. To focus on the aspect of apparent flow, he urges, is to miss our identity with time in favor of a view on which we're carried along like boats in a current by time. And here's his discussion there. The lack of distinction between events and time itself is obscured when we think of time as a flow or as a river in which events float along from future to present to past. And this brings us back to Nāgārjuna's initial insight. Time is not something extra, an entity or a super entity that contains all of the events and objects that constitute the world. Positing that extra being would only involve us in a regress. This, however, is not to deny flow in another sense, as impermanence and as the anisotropy of time itself. It's just that we can't divorce that sense of flow from the Minkowskian idea that flow is nothing but the anisotropic dimension of something that is nothing but an omnipresent structure when seen from a different vantage point. We don't want to go there yet. The flow Dogen emphasizes here is not like a storm moving across a landscape, one thing changing places with respect to another. The past, present, and future do not alter their positions. We don't move from future to past, nor does time flow past us, nor does it flow in some super time at the rate of 60 minutes per hour. Instead, temporal flow in its reality is just like a season, such as spring, in a vast manifold of events over which a partial order is defined. And that order is defined by natural processes, not by the primordial ordering of an extra being. Dogen and Tsongkhapa, we've seen, draw similar morals from Nāgārjuna's analysis in Mula Madhyamaka Karaka 19. But while they're not in tension with one another, they're not identical morals. Each has something to contribute to our understanding of the metaphysics and the phenomenology of time. Tsongkhapa directs us to the centrality of dependent origination and the impermanence of phenomena as constitutive of temporality and of the non-duality of time and being. Dogen draws our attention to the merely apparent duality of the two aspects of time. Time as flow and time as omnipresent, showing that they are simply two ways of experiencing the unity of time and being, and reminding us that our own being is also temporal. I take these to be profound insights into our experience of time, both the illusory experience that colors so much of our ordinary consciousness of inhabiting this independent temporal vessel, and the more profound experience of ourselves as temporal, to which we are invited by Dogen and by Tsongkhapa, as well as into the metaphysics of time. And for these insights, we should be grateful to the Buddhist tradition. Now some final thoughts on Buddhism and modern science. This gratitude, however, should not lead us to misunderstanding. Neither Nāgārjuna nor his canonical commentators in medieval India were scientists. And any dialogue we imagine between the metaphysical views they advanced and the discoveries of theoretical and theoretical perspectives that have emerged in physics over the last century and a half would involve a great deal of talking past one another. Not all of it, but a lot of it. This isn't to deny that there are interesting homologies between the thoughts that emerge in classical Buddhist philosophy and those that emerge from relativistic physics and quantum mechanics. And I've been emphasizing those homologies because that's where we are. They each emphasize thoroughgoing interdependence and the observer relativity of ontology, and as we've seen, a rejection of a container view of time in favor of a relational view. But these instances of broad philosophical harmony should not blind us to the enormous differences between these frameworks. And I worry that the kind of industry of Buddhism science dialogues often ignores those differences in the enthusiasm for what's shared. And that's when we get into that tawdry swamp of which Bob reminded us. So I'm trying to de-tawdrify this for a minute. Madhyamikas do not accept the possibility of fundamental particles, for instance, and they criticize rival Buddhist schools for suggesting that there might be an end to material analysis. There's no way to say particle-wave duality in Sanskrit that would make any sense in a classical Buddhist world. And statistical inference, which is so central to physics, to quantum theory, to everything that we do in science, the idea of randomness and the idea of probability play no role in classical Indian, Tibetan, or Chinese worldviews. And if you want to set yourself up for a really frustrating experience, try teaching probability theory and statistics in a Tibetan monastic university. It's really fun when you just repeatedly are told, no, there is no randomness, no, there is no probability. It's really, right, so it just goes like that, right? Neither contemporary physics nor the philosophical positions it inspires have much time for yogic perception, Buddhahood, or the soteriological significance of the theories that these folks advance. These differences in outlook are so significant that even apparent similarities can sometimes be treated as merely verbal. And we've got to really be careful to sift what's really there from what's not. To take the case at hand, it's true that Buddhists might agree with at least some contemporary physicists and philosophers of time regarding the interdependence of time and temporal entities. I think so. Regarding the need to see time more as structure than as entity. I think so. And even perhaps regarding the basis of the anisotropy of time, which I think is really cool. Nonetheless, the differences that remain are so deep that they may make Buddhism irrelevant to contemporary physics, except as a point of comparison and illumination. For instance, Buddhism has got nothing whatsoever to say about the unity of space and time as a single manifold, and that's really hard to even say in the Buddhist literature. And no canonical Buddhist account of time or space addresses the relation between space and time in those terms. Nor do any canonical Buddhist philosophers imagine the perturbations of space and time by gravitation. You just can't say that in these texts. It doesn't even make any sense. Let alone the profound distortions of space-time in the vicinity of black holes. Indeed, the idea that space-time could be represented geometrically has no place in Buddhist thought. Differences this profound almost suggest that, as Prasangika Madhyamikas would see it, there's no common subject for debate. That is, that we're using our terms differently. That any conversation across this chasm would be impossible. I'm not that pessimistic, right? I wouldn't be here if I was that pessimistic. I'm not that pessimistic. But I do urge that we all be cautious. And I would venture a hypothesis, one akin to a view that I once defended to howls of derision at a conference on Buddhism and cognitive science, but which I would still defend. Buddhism has more to learn from physics in this domain than physics has to learn from Buddhism. Buddhist ideas about interdependence, interpenetration, structuralism, and about the relativity of ontology to consciousness can be made more precise using the language, findings, and formalisms of modern science. I would prefer to see Boltzmann, Planck, Einstein, Heisenberg, and Rovelli imagined as Buddhist commentators than to see Nāgārjuna, Tsongkhapa, and Dogen treated as early physicists. The first strategy elevates science to the level of philosophy. The second only creates OTO's physicists manqué. Thank you. There's our...
I just want to start off with actually just a comment about your last point. I don't think, especially for this conference, that we're trying to say like, oh look, physics says this, doesn't Buddhism say that as well? In fact, actually what's happening right now, there's a crisis in physics on multiple fronts. Things like, where to go with quantum gravity, the nature, understanding life from a physical point of view. And I think in some sense what we'd be doing is we're looking to Buddhism as, or that stream, for another set of ideas that might be drawn upon. Physicists are used to, when they reach frontiers, drawing on, previous philosophical views. That's why you see all these, Greek terms suddenly picking up. And so it's not, we're actually looking, if we're going to use Buddhism, we're using it as a set of ideas to maybe take a next step that we don't know when we've sort of run out of steps to take.
And that's the right way to do it.
Yeah,
I've seen too much of the wrong way, too.
Right.
I want to make a very technical comment here and see how you react to it. In the surround the spirit in which you nicely put in the last comments of your talk about what is in common, what is different, and what we can use from one side to the other. And this regards the part of your talk in which you talk about you call it anisotropy of time. In my environment, it's more called the directionality of time, because anisotropy is more connected to speed. So there's something that hit me, and both in the sense of an analogy of a difference, which is the following. Try to say it correctly. I completely understand, and it's beautiful, the similarity you drew between the idea of reducing the directionality of time, the anisotropy, to the causation, to the causal structure that we're talking about, and Boltzmann, which also somehow reduces the direction of time entirely to some feature of the phenomena, which are those ones which are reversible. So fantastic! I see the point. Of course, there's a missing link if you want to play this game, which is the exact relation between causation and the thermodynamics arrow of time, which are not the same thing.
Right.
And it is the opinion of some people, including myself, there is a strong opinion for myself, that, forget Buddhism for a moment entirely, within physics, the arrow of physics, there are three sort of breaking of time symmetry, which is the epistemic arrow of time. We know the past and we know the future. The agency arrow of time, we can affect the future but not the past. And the causation, the cause comes before the effect. Okay, so it's my strong conviction that all three can be made sense, rooting them into the thermodynamical arrow of time. So we can understand them as manifestations of the contingent fact that we are integrated.
Yeah.
If it is so, this is a missing link between the direction of time and causation, and this brings the view of directionality, which is in fundamental physics, at least according to me and others, to the one that you describe. But where now causation is not so primary as in Buddhist thinking, where it is primary. So all this thinker you're describing tend to take the causation as one of the main ingredient from which you, while from this perspective, it's a contingent entropic structure of the universe, the fact that we live in this gradient of entropy, that has a consequence, that we remember the past and we can connect with the future, and that we can talk, because of that, we can talk in terms of causation in the future. So in a sense, this is coming very close, but then divergent. This causation then is it's epistemically close to us, but it's we reduce it to something else strongly. Do you have a comment on that?
Yeah, I think maybe not as much of a difference as you think. That's not to say identity, but not as much of a difference. Because as you correctly emphasized in your talk, causation in a Buddhist world is understood as one of the dimensions of dependent origination. And the more fundamental notion is dependent origination. And so mereological dependence, conceptual dependence, causal dependence, they're on a par. They're all facts about the interdependence of phenomena. And Tsongkhapa's insight, I mean, well, the reason that I'm so taken by it is that focusing on dependent origination, so when he's thinking about disintegration, he's thinking about that as an aspect of dependent origination. Focusing on dependent origination and, as you say, the contingent fact that we live in a thermodynamically structured universe, that's okay. Because when you say contingent, I hear conventional. When I hear conventional, I hear actual. And actuality is all you want. That is, if you're asking for necessity as opposed to contingency, then you are asking for the kind of transcendent foundations against which both Buddhist philosophy and quantum theory argue against. So I guess while I agree with you that what this does is it replaces, as Kant would put it, a transcendental condition on existence and experience, that is temporality itself, with a contingent fact, that is the thermodynamic structure of the universe. That's how it should be, because when I hear modality, I get nervous. Yeah.
I see. So if you write the causal structure itself should be taken. So
Yeah.
I see.
It's remember the first chapter of Madhyamaka Karika.
Yeah, we saw against that.
Yeah, the first chapter is all about why dependent origination is also empty of intrinsic identity. And that means it's going to be contingent. And it's going to be itself dependently originated. And that's what you expect. And if you take that seriously, and if Tsongkhapa's right about that special role of that it's a one-way process, as it were, then you get temporality for free, as Boltzmann thought you did out of thermodynamics. And I think that's kind of cool. That's all. Or hot, depending on.
Thank you. That was really awesome. 90% chance this is me not understanding. When I think of the anisotropy of time, I think of a fundamentally, it's a tenseless thing. You know, so I'm privileged, it's a way of privileging the earlier than or the later than relation, or a way of picking one out.
Yeah.
And so then when you go to Boltzmann, he does this via, this awesome insight was doing this via the most likely direction of entropy increase. When you came up to this Boltzmann-like insight, though, you were maybe that is where I misunderstood, but you were using a lot of tense language.
Yep.
So it was all about present flow, now, past, present, future, and then that's not. And then so is the reduction of the tense to the tenseless, or is it the giving of a direction?
Yeah, that's a really good question, and it comes. I'm going to answer it in a way that might feel like a cheat, but I hope it doesn't. And it comes back to my admonition at the very end that we want to be delicate about our homologies here. Tsongkhapa is not thinking about, cognizant of, debates about tensed versus tenseless versions of understanding time, and he's not talking in that language. And his language is pretty thoroughly tensed. But what he is doing is arguing that we can make sense of tense in that sense by thinking not of the tenses as marking locations in time in which events occur, but rather as deriving from something in the structure of events themselves. Now that, as I say, it's not Boltzmann. He's never heard of thermodynamics, right? But what he sees is when things disintegrate, you don't put them back together. And that's the insight, right? That's perilously close. Not there. We don't have thermodynamics. We don't have statistical mechanics. I don't want to claim that we do. What we do have, though, is an insight that we can understand tense by looking at physical processes. I think that's okay.
One last question.
Okay, just a quick follow-up. I mean, I feel like there's just a tension in the idea of looking at disintegration as a foundation for time or temporality in Buddhism because, what we've been so far kind of calling to attention is that, everything is relational. And there's going to be some kinds of relational connections according to which what appears to be a disintegration from one perspective is going to be a creation from another. So,
That's right.
you know, anything that, so when I die, then I will be a wonderful feast for worms. So,
Yep.
anyway, I
That's right. So, you know, and as Dogen says, you know, firewood becomes ash, ash doesn't become firewood. And I think he's pointing out that that duality is really an important duality. Disintegration isn't absolute either.
right.
So what we're not doing, and what Tsongkhapa would never be doing, is saying, I'm going to give you the foundation of temporality. Because this, as Carlo emphasized, is an anti-foundationalist project. Rather, what he's going to say is, if you want to think about temporality as a property of an independent temporal structure, I can do you one better. This doesn't mean that when we disintegrate, we don't get new entities, any more than it means that when we measure a system, we don't get a new system. What it does mean, though, is given this kind of unidirectionality of temporality and, if you want, the construct of disintegration and the things to which disintegration leads, we can still reconstruct a temporal order out of that. And I think that's okay. I mean, this is 14th century philosophy. This is not microphysics. Yeah.
My claim is that for every disintegrating temporal order you arrive at for some sequence of events, I can come up with another like relational structure that would go another direction.
Yeah, you can. So the question is, which relational structure do we look at? And Tsongkhapa's argument is the one we look at is disintegration.
Okay.
Right? I mean, you're right. There are other physical relations. He's pointing out one that gets you temporality.
That's picking out a certain set of the conventional relations as being the ones that
That's right.
somehow are associated with time.
That's right, and that's meant to be contingent.
Okay.
Yeah. So, but you know, the world's like that. Thank you for the question. It was a really nice one.
I wanted to thank Bob and Sanjo for their help in organizing this awesome conference. It's been a long time coming. So it's amazing to all be here. So today I'm going to be looking at the notion of indeterminacy, and I want to start by observing that, just like by way of overview of the talk, that to start, on certain interpretations of quantum mechanics, it's most commonly observed that this is true of the orthodox interpretation, but arguably it's also true of the so-called GRW and the Everettian many worlds interpretations. Quantum mechanics gives rise to indeterminacy. This notion of indeterminacy in the first instance is associated with the thesis that, contrary to the traditional classical assumption of value determinacy, the observables of a given particle or system, where an observable is something like a property or a state, cannot all be given perfectly precise values at the same time. So, classically, we thought we could do that. In quantum mechanics, with few exceptions, it looks like that's not possible. And interestingly, as well, on certain schools of Buddhist thought, and here I'm going to focus on the Chinese Madhyamaka school, associated with Seng Zhao, I hope I'm pronouncing that right, and Zhizang. There is also indeterminacy, which is associated with a Chinese Buddhist interpretation of Nāgārjuna's doctrine that all things are empty, as the doctrine that all things are lacking determinate nature, existence, features, and form, and so on. So what I want to do today is provide reasons to think that, notwithstanding the really incredibly different contexts which are supporting these forms of indeterminacy, they actually have a lot in common. As regards, in particular, the metaphysical status of the indeterminacy that's at issue, the source or structure, at a certain level of abstraction, the source of the indeterminacy at issue, and also the proper treatment of the indeterminacy at issue. So there are some accounts of metaphysical indeterminacy on offer, and I'm going to suggest there's one that works well for either quantum or Buddhist indeterminacy. So more specifically, what I'm going to do is I'm going to start by making the case, or at least gesturing to certain assertions to the effect that quantum indeterminacy
on a wide variety of interpretations, as well as Buddhist indeterminacy in the Madhyamaka tradition, are naturally seen as involving properly metaphysical indeterminacy, by way of contrast with, in particular, indeterminacy of the sort where really, the states of affairs at issue are perfectly determinate, but we just are not in epistemic position to know what those determinate values are, or what's sometimes called semantic or representational indeterminacy, according to which, our terms for certain notions just haven't made up their minds, so to speak, what the proper extensions of the terms or expressions should be. So that would be a form of representational indeterminacy. So first thing, to just try to establish that, in fact, there's a case to be made that the indeterminacy in these cases is properly metaphysical, or, as it's sometimes put, worldly, in the world, not in our minds or in our ignorance. And then I also want to argue that superposition-based, in particular, quantum metaphysical indeterminacy and Chinese Madhyamaka indeterminacy, metaphysical indeterminacy, have a structurally similar source. Okay, so I won't say what that is at this point, but you'll see. And then I want to go on and suggest, as I already prefigured, that of the kind of live options for understanding metaphysical indeterminacy that are presently available in the philosophical literature, one of them does better than the other for both quantum and Buddhist indeterminacy. And moreover, within that account of indeterminacy that can do this job, there are different ways of implementing that good approach to metaphysical indeterminacy, and I'll argue that actually they are both implementing this particular approach to metaphysical indeterminacy in the same way. So there's actually quite a lot of similarity between these forms of indeterminacy, and if there's some time, I'll gesture, hopefully not just to the similarities, but also to a couple of potential applications of, this consonance that might inform the disciplines in one direction or the other. Okay. So first of all, quantum metaphysical indeterminacy. So what is this indeterminacy really based in? It's in the first instance, value indeterminacy or indefiniteness, and this is supposed to lie at the heart of what is distinctive about quantum phenomena. And there's many of these classic cases that you will have heard about. For example, prior to detection, the location of a particle in the double slit experiment is indeterminate, or prior to opening the box, Schrödinger's cat is neither determinately alive nor determinately dead. A particle cannot have, or system cannot have precise values of both position and momentum at the same time due to duality. Another source of indeterminacy or case of quantum indeterminacy, the components of a spin entangled state do not have determinate values of spin, not all of them. So now on the interpretations that I have in mind, the indeterminacy in these cases is taken to be metaphysical, not epistemological, not merely semantic. So for example, Joanna Wolf notes on an orthodox reading, quantum mechanics suggests metaphysical indeterminacy, not merely epistemic indeterminacy. George Darby also notes more generally that there are obstacles in the way of interpreting the indefiniteness at issue in quantum mechanics as merely epistemic or representational, such that quantum mechanics looks like a likely source of examples of genuine metaphysical indeterminacy. And here Darby is adverting to certain, seeming no-go theorems associated with a Kochen-Specker theorem. I'll say a couple words about that down the line, but also with the idea that, complementary phenomena, duality phenomena just indicate that, as a matter of fact, you're not going to ever be able to fully specify all properties of a system, much less the world, as fully determinate at a time. Okay, so that looks like metaphysical indeterminacy, and one of my co-authors on this topic, Claudio Colosi, and I have also argued that basically Wolf and Darby and some others had been focusing on the orthodox interpretation, but we also try to argue that there will be lingering metaphysical indeterminacy on the GRW and Everettian interpretations as well. And more recently, Alistair Wilson has written a book in which he focuses on Everettian quantum mechanics as a kind of basis for modality, and he again talks about how there is, in fact, metaphysical indeterminacy, both in world number, how many worlds are there, so to speak, as well as world nature. And we have followed up on that. So I think at this point there's some really good cases out there suggesting that a plausible way of understanding this indeterminacy is as properly metaphysical. Now let's turn to Buddhist indeterminacy. On certain schools of Buddhist thought, and again, I'm going to focus on the Chinese Madhyamaka school. There may be other traditions as well in Buddhist metaphysics, so I'd be interested in learning more about that. But this is one school of Buddhist thought where it looks like, yes, there's also indeterminacy. And this is associated, as I said, with Nāgārjuna's doctrine that all things are empty as being the doctrine that all things are lacking determinate nature. So Chen-Sing Ho, in particular, is the one who pretty much turned me on to this connection of, Buddhist that there was a case to be made for Buddhist metaphysical indeterminacy. And I won't, in the interest of time, I'm not going to read this long quotation, but he talks about how Chinese Madhyamaka kind of grew out of Indian Madhyamaka, and Nāgārjuna's view that everything has this no independent and invariable nature got interestingly translated in certain ways and interpreted in the Chinese context as the claim that not just things are lacking, not just kind of a negative claim that things are lacking in nature or intrinsic nature, so to speak, but also with a special spin on this nature's being indeterminate. Okay, so this reflects in a way some of the translations, but also the interpretations of the Chinese people who were reading this and developing it. So that led the Chinese Madhyamakas to think that for things to be empty in the Madhyamaka sense is for them to be devoid of determinate nature and form. So that's how we transition, so to speak, from Indian to Chinese Madhyamaka is very interesting. This is at least one strand of kind of interesting evolution, so to speak, in the notion. So then here again, Ho wants to make the case that the indeterminacy is on the face of it properly metaphysical, not just epistemic or representational. So he says the Chinese Madhyamakas locate the lack of determinate nature and form in what they commonsensically take to be things, that is, things in the world. They would not think of the world as a determinate array of determinate things or facts. Thus, it makes good sense to think of the indeterminacy exposed in the characterization as worldly. Okay. And he goes on and characterizes indeterminacy in this Buddhist tradition via what he calls Madhyamaka-based ontological indeterminacy. He uses the word ontological just to kind of flag that there might be some differences here between the kind of indeterminacy that's associated with certain accounts of metaphysical indeterminacy in more the philosophical literature, but it's properly metaphysical. So MOI, for a thing X to be ontically indeterminate at a time with respect to the way it is, where this covers its existence, its nature, any property it might have or not have, its form, etc., is for X to be such that no concept or expression can be conclusively applied to X at that time, in the sense of representing definitely the way that it is. So he says, and he has this nice example of a daffodil. So if the word daffodil were to represent definitively the way that a given entity was, then X would be finally, non-relatively, and exclusively a daffodil and not any other kind of plant or thing. Okay? But ontological indeterminacy on this understanding entails that an ontologically indeterminate X cannot be so represented. So we cannot give a name such as daffodil that would conclusively and determinately represent any entity for any such object. But what we can do is we can provisionally determine something, X, as such and such, but any such determination that you might impose on an entity would never be to the exclusion of other potential determinations, right, of that entity as something different from a daffodil. And no determination is definitive. So there's not just one proper way of representing it as being the way that it really and truly is. Thus, X is not definitively or conclusively determinable in the sense that it cannot be given a conclusive determination. That is, it is not capable of being determined as definitively such and such or as definitively possessing this or that feature. So that's a cool view. Yeah, kind of, mind-blowing, but worth trying to make sense of. So now, first of all, though, given that this talk, so he's characterized MOI, Madhyamaka, ontological indeterminacy, he's characterized this indeterminacy in terms of talk of what can or cannot be represented. So that might lead you to wonder whether the indeterminacy that's at issue here really is worldly or metaphysical. Might it not just rather be semantic, that our terms aren't up to the task of definitively representing something as the way that it really and truly is? However, Ho clarifies that's not what is going on here. On his view, and as per the view he's trying to characterize, worldly and semantic indeterminacy are both present. So he's not saying, and really it doesn't have to be one or the other. We could have, in some cases, all three present at a time. So in this case, he just wants to point out what was already encoded in his previous quotation, that, somebody wanted to try to make out that it was really just semantic indeterminacy that was at issue, then you might claim that it was just if we could get the rules for our words in order, then we could conclusively determine something as being such and such a way. But that's antithetical to the intention of the view he's trying to represent. According to ontological indeterminacy, there are no such kinds of determinate things. So it's not a matter of our getting our language in order. So in that case, why does he use representational language, or why does he express MOI in broadly semantic or representational terms? I think this in a way is broadly contingent, but it probably just represents that in some of the relevant texts, Nāgārjuna, Shizang's, and Zhengzhao's characterizations of emptiness, they often do so in terms that refer to human conceptualization, and how we would in fact determine something as being the way it is. But as I understand it, people who are working on these and other Buddhist texts can correct me if I'm wrong. Really, that's dispensable. The kind of indeterminacy is one that could involve rocks and other kinds of inanimate objects and so on. So all these variable representations, there's this sense in which that it doesn't actually build in the notion of, conceptualizing creatures as foundational to the indeterminacy at issue. In any case, the indeterminacy in MOI is supposed to be irreducibly metaphysical, and again, notwithstanding that it's characterized in these semantic terms. Okay. So that's, I think, a really important point of connection between quantum and Buddhist indeterminacy, and for my purposes, it's really huge, because as somebody who's interested in metaphysical indeterminacy, and I have, as you'll see, my own preferred approach to this topic, quantum mechanics has so far been kind of the best shot that for making out that, in fact, there's a phenomenon here that deserves to be looked into, considered whether we can, in fact, make sense of it, and so on. So that's great. I think there actually is quite a lot of metaphysical indeterminacy with respect to, for example, ordinary object boundaries and the like, but people will be, are friendly to saying, oh, well, that's just a matter of how we're using our terms. They'll just say, oh, yeah, that's a matter of semantics, maybe epistemics. But if you actually have a case to be made, a hugely, prevalent line of thought according to which, in fact, there is genuine metaphysical indeterminacy, then I think that offers another wonderful case in point. It sort of supports the interest of my own research, and of course, that's what's most important to me. So anyway, thanks to the people who are working on Buddhism, and in particular Sheng Ho for kind of filling in, drawing my attention to this really very, very interesting source of metaphysical indeterminacy. So now I want to turn to what I think is kind of a really also very interesting source of commonality between the forms of metaphysical indeterminacy at issue in these cases. So let me just start by saying that with respect to quantum indeterminacy, my co-author in crime, Claudio Colosi, and I, in a paper titled Quantum Metaphysical Indeterminacy, we identify three seemingly different sources of quantum metaphysical indeterminacy that might be operative either in cases of superposition. So that would be, for example, a case where a system fails to have any determinate value of some one observable. For example, Schrödinger's cat has a certain life status but isn't determinately either dead or alive. Or a particle in the double slit experiment, it travels from the emitter to the detector but doesn't have a determinate trajectory through one or the other slit. That's one kind of source, superposition, QMI. Another source that we identify is involving incompatible observables. We already spoke about those, so position and momentum being, a primary case in point, or spin values in orthogonal directions cannot all be given precise values at the same time. And then a third one involves entanglement, where you have the failure of components of a composite system to have determinate values of certain observables. For example, a case where you had spin values of components in this EPR singlet state where you have a particle that, entangled particles that are space-like separated. Now, as we discuss, perhaps, and it's probably likely that one of these sources is prior to the others, probably superposition is really the deeper quantum generator of the indeterminacy here. However, there are interesting mathematical and we think metaphysical differences between these cases. With that said, I just want to kind of bracket the idea of this question of, which of these might be prior and exactly how, and just focus directly on superposition. As per these two paradigmatic cases involving Schrödinger's cat in this state of being alive or dead, as per this little equation here, and a single electron in the double slit experiment, where, in this state, superposition state, where it's represented as having gone through the one slit, but not the other, and vice versa. So now what I wanted to point out is that in these cases of superposition, Schrödinger's cat, the particle, electron, and the double slit experiment, it's very natural to see what's going on there as involving somehow or another that both of the determinate values are instantiated somehow or another, okay? So if you look at the formalism, those little equations, they've got a conjunctive form. It looks like they're both present and they're, somehow, Schrödinger's cat looks like, well, it's kind of alive and it's kind of dead, right? It's not just in a state that has nothing to do with those determinate values. So looking at the formalism, that's certainly suggestive that, somehow or another the determinate properties or states are actually both somehow instantiated. And interestingly, descriptions of physicists will often kind of represent or reflect this kind of thought. So for example, when Einstein was describing Schrödinger's cat case, he will do so in what I call glutty terms, where the idea is that, the indeterminacy is in a way reflecting that we've got too many determinants on the scene. So Einstein said at a fixed time, parts of the psi function that should correspond to the cat being alive, and other parts to the cat being pulverized. And this is also suggested by the double slit case, in my view, in a very interesting way, because on the face of it, the double slit case is interesting because you're getting interference phenomena, even though you're just sending one particle through, right, from the emitter to the detector, so the two slits are open, you would expect it can only go through one. But somehow it's going through both. And the question is, how could that be? at this point, I just want to point out that Dirac, for example, said, well, look, so long as the photon is partly in one beam and partly in the other, then the interference can occur when the two beams are superposed. So, the double slit case provides an especially nice motivation for thinking that there must be, in some sense, they're both jointly present in order to actually provide a basis for the interference phenomenon, because that would be cool. But of course, then the tricky part is understanding how could it be that both of these determinate properties or states are instantiated when they're intuitively incompatible. A cat can't be both dead and alive. A particle can't go through two slits through independent trajectories, incompatible trajectories at the same time. We have to say more about how to try to make sense of that, but it at least gives you a basis for understanding the failure of the system to have a determinate value of the observables in question, because that would reflect that the instantiation of one of the determinate values, right? In a case of superposition, it doesn't rule out the instantiation of the other, right? But if you were to say, oh yeah, the cat is alive, right, without any relativization or qualification, then that would entail that the cat was not dead. But in a case of superposition, saying, well, the cat is in some sense alive, doesn't rule out that the cat is in some sense or is dead or definitely dead. So what you're left with is something indeterminate, an indeterminate state. Okay. Now, interestingly, in MOI, you can see a similar, I think, a very similar phenomenon, a structurally similar phenomenon. So remember that, as Ho put it, any given object on this view is not capable of being determined as definitely or definitively such and such, or as definitively possessing this or that feature. And why is that? That's because any such determination is never to the exclusion of other determinations, right? And no determination is definitive. Similarly with the superpositions, I think. I'll say more about that in a second. But he does offer the following remarks in support of that characterization. Again, just for the sake of time, I'm not going to read all this through, but the idea is that, as we've already been seeing in the previous talks, the suggestion is that it's really characteristic of Nāgārjuna's and then developments of Nāgārjuna's thought that there are multiple perspectives, multiple relational connections that are associated with any given entity, and none of them are privileged. They're all, that's not to say all, any relational thing goes, but of the relational possibilities that are in some sense relationally definitive of something, or that enter into an entity's contingent relational manifestation or expression, none of them can be picked out as definitive and conclusive as being the one really that expressing the way that the entity is. Okay. So again, it seems to me that given this view, here too we can locate the metaphysical indeterminacy as reflecting this very unusual, from a classical perspective, unusual understanding on which an object can be in some sense the proper subject of multiple incompatible property attributions, right? Schrödinger's cat, double slit experiment, the daffodil, right? Those are all cases where the idea is that the object that at issue can be in some sense the proper subject of multiple and incompatible property attributions, so to speak. Okay. So it seems to me that this understanding of the source of metaphysical indeterminacy in the Chinese Madhyamaka tradition bears a very close structural resemblance to the source that's at issue in superposition QMI, just as I was kind of just more or less saying. So it seems natural in particular to apply Ho's description to the case of Schrödinger's cat. So prior to opening the box, one might provisionally determine the cat as alive. Why? Well, after all, it's not true that the cat is not alive, right? And you could also do that for the cat's being dead. You could provisionally determine the cat as being dead. Why? Because, it's not that it's not. It's not that it's dead. But any such determination is going to be, quote, never to the exclusion of other determinations, and no determination is definitive. So these multiple determinations are on a par, in a way. So there's that kind of, I think, a deep structural similarity between, at least superposition, quantum metaphysical indeterminacy, and Chinese Madhyamaka indeterminacy. Interesting question, I think, is what about the depth, as I put it here, the depth of the metaphysical indeterminacy in these contexts, in the sense of, is there some way of overcoming the indeterminacy that's at issue here? So far in MOI, all that's doing is telling you what it would be on this view for an object to be ontically indeterminate or metaphysically indeterminate. But, as that characterization enters into the general Chinese Madhyamaka position, the general position is that everything is insuperably indeterminate. So not just some x's out there, but every x is subject to ontic indeterminacy as per MOI. Now, what about in the quantum context? Is it also the case that quantum metaphysical indeterminacy is insuperable in this kind of very widespread or irreducible way, so to speak, such as, not to be ever conclusively resolved, so to speak? You might think, thinking, oh yeah, well, can't we just open the box? And then we can resolve that indeterminacy. The cat's dead, or the cat's alive. So in that case, once we open the box, suppose the cat's unfortunately dead, we can't, put the cat back in the box and hope that next time we open it, then we're going to find out that it's alive. However, in other cases of superposition indeterminacy, it is the case that you don't ever get conclusive determinability of a determinate value. So if you have, for example, a particle and you measure it in, as spin x up, that throws its status, spin up or down, in the other orthogonal directions into a superposition, which is ergo indeterminate. But now if I go and I measure the same particle along one of these other, I resolve the superposition in the other case, and it's going to throw the previous x spin value into a superposition as well, and so that's going to render that now indeterminate. So I think if we look at some of these cases of superposition, oh good, this gives me a chance to get some water. Then in that case, the determinate outcomes will in fact be irreducibly provisional in just the same way that they would be, or maybe not in just the same way, but still there's a case to be made that the, any determinacy is in some sense provisional. And I also have here a quotation from Arsenius, which is getting at some of the sort of considerations that Carlo was mentioning as well with Wigner's friend and so on. This question about how, the role of the measurement apparatus and superpositions, lingering superpositions for observers of observers who collapse the wave function and so on. So there's that too. And then finally, at the level of the world at large, because of these, because of the irreducible, features of duality, as well as some other, sort of no-go theorems, we have good reason to believe, at least on the majority of these interpretations, not all interpretations of quantum mechanics, but on the majority of them, it turns out that, there's just no way ever to make it the case that determinate values can be assigned to all features of all entities at a world. So the indeterminacy is also insuperable in that sense. So that's another kind of interesting connection, I think. So now, what about accommodating quantum and Buddhist indeterminacy? If we want to try to accommodate these forms of metaphysical indeterminacy on, their own metaphysical terms, what are our options for doing so? There's two main accounts of metaphysical indeterminacy on offer. Before I get started, let me just ask, how much time do I have still left? I can gloss over.
29 minutes and 54 seconds.
29
minutes.
Really? Just for talking or for the whole session?
The whole session.
Okay, good. So let me try and finish up quickly then. There are two main counts. Here's a heuristically useful way to think about what's going on in these two different approaches to metaphysical indeterminacy. On one kind of approach, the world itself, every state of affairs or whatever, is in fact perfectly determinate. But somehow the world is unsettled about which determinate way it is. Okay? Okay. You might think that's a little odd, but you could think about, for example, the open future. I think that's a nice way. So suppose you think that the open future, there's a genuinely open future, and you're like, well, look, there's either going to be a sea battle tomorrow or there's not going to be a sea battle tomorrow. Those are the only options. But right now it's unsettled. The decision, whoever is going to make that decision, they haven't actually made that decision. There's free will. So you could think about the world is right now unsettled about which determinate way it's going to be. But it's going to be that determinate, one of the other of those determinate ways. Now take that line of thought and try to apply it to present tense indeterminacy. A little trickier, but the idea is that somehow you can make sense of the world being primitively determinate among the determinate options. So there's the fact of the matter that the world, that there is a determinate option, and the world really is one of those ways, but somehow the world hasn't made up its mind about which way that's supposed to be. That's not my view. I mean, I find it hard to make sense of that view for present tense indeterminacy, but look, it has logical. There's a logical apparatus, semantic apparatus. It's sort of a variation on well understood themes and so on. So there is, but my main point is that is just one of the ways that one could understand metaphysical indeterminacy. However, crucially for our purposes, it assumes that at the first order, so to speak, at the object level of goings on, those are all determinate, right? And the indeterminacy is just located at what I sometimes call the meta level, just to say, look, every state of affairs is perfectly determinate, whether the particle went through the left slit or the right slit or something, but somehow it's just indeterminate which way it went. Okay, that's one option. Indeterminate which determinate way things are. Now, on my preferred view, is rather the case that metaphysical indeterminacy, at least sometimes, involves it being determinate or just plain true, that there's an indeterminate state of affairs. So on my preferred view, indeterminacy can be located, and for some cases should be located in the objects themselves somehow or another. And I cash out this so-called object-level approach to metaphysical indeterminacy in terms of determinable and a relation that you may or may not be familiar with, but it's a relation called the determinate relation. Paradigm case is, say, colors and their shades. So, for example, red is a determinable shade of color. Scarlet is a determinate shade of color. And often you will have a determinable property or something, and there will be multiple determinate ways it could be. Just like red could be scarlet, it could be crimson, burgundy, and so on. On my, the precisification of my approach, this object-level approach to metaphysical indeterminacy, what I say is that what it is for some state of affairs to be metaphysically indeterminate at a time, basically, is for the system, whatever it is, the object or system, to have a determinable property, a kind of general property like being, red or something, it's not maximally precise, and to have no one unique determinate of that determinable property. So, that's the view. So it turns out there's a couple different ways that this view can be implemented. You could have a determinable property and there's no determinants around to be even candidate determinants of this property, right? That would be kind of an unusual case, but you might think that some cases of indeterminacy are like that. But more commonly, perhaps, that's called gappy indeterminacy. More common is a kind of indeterminacy of the glutty variety, where you have some object or system has this determinable property or feature, And there's too many candidate determinants around for that are, it could be, right? You're probably already thinking ahead. This is sounding a little bit like Schrödinger's cat or something like that. So if you were thinking of that, then that's good, because that's where I'm going with that. But I'll get there in a couple minutes. A couple things I just want to point out. I'm going to skip this business about some other points of difference between my view and what the first view I discussed. But what I want to point out is that interestingly, and I'm quite happy about this, it's been recently argued first that for both quantum indeterminacy and for Buddhist Madhyamaka indeterminacy, first of all, a metaphysical supervalue, the first kind of view that I was talking, a meta-level approach to metaphysical indeterminacy won't work, can't accommodate the kind of indeterminacy that's at issue, and that the kind of object-level account that I endorse will work, okay? Now, just to sketch how that would go, with respect to quantum indeterminacy, I think it's pretty obvious why. There's a lot more to say here, as per usual, but kind of on the face of it, it's unclear how that approach to indeterminacy could handle insuperable quantum indeterminacy, because basically this approach assumes that the world itself is completely determinate in all respects. And to the extent that there's any indeterminacy, it's just in the world's being unsettled, which precise way it is, right? But that's just the wrong model for quantum metaphysical indeterminacy of this insuperable variety, right? Whether we're talking about a specific state, like Schrödinger's cat, it's just not, it doesn't properly model the facts to say that, well, Schrödinger's cat really is either alive or dead, but the world just hasn't decided which one, okay? You can say that, but it just doesn't seem like it's the right way to go to properly model this view. And if you think about the world as a whole and this kind of, the no-go theorems, which suggest you just cannot properly model the world in quantum terms as having assigning determinate values of all properties to all entities, then in a way this meta-level approach to metaphysical indeterminacy is just assuming something false, something that is nomologically impossible by lights of quantum mechanics. Okay. By way of contrast, the kind of determinable based approach to metaphysical indeterminacy that I endorse, it looks good for quantum mechanics. In Schrödinger's cat case, you can think, well, look, the cat has a determinable property, something like having a certain life status, right? And, there's just too many candidate determinants on the scene. Again, there's in some sense instantiated, there's like the being alive, being dead, but we can't assign one of those to the cat, right? And because they're just equally good candidates for being the determinant of that determinable. And similarly for the double slit experiment. Okay. So we also argue, and so does Ho, as regards Chinese Madhyamaka indeterminacy, that a specific way of implementing my preferred approach makes a lot of sense. Again, it's going to be this kind of idea, though, that basically how are we going to make sense? Let me just say very briefly, how are we going to make sense of, for example, Schrödinger's cat somehow, having both of these determinants instantiated without contradiction, right? Or how are you going to have this object be both a daffodil and not a daffodil without contradiction? Well, you have to relativize, right? You have to somehow or another relativize the different determinate values to something. And then what that something is, how you're going to fill in that gap for the quantum case or for the Madhyamaka case, it will depend. It could be causal, conventional, constitutive, etc. Over here, maybe it has something to do with, in the case of Schrödinger's cat, good question, what exactly those perspectives are going to be. Double slit experiment, maybe something like relativizing to all the possible trajectories that the particle could go through the one but not the other, and so on. Here's a simple case which may illustrate, and then I'll use that as a model, and then it's like exercise for me for future homework to try to figure out more details about that. But like if you look at an iridescent feather, for example, iridescent feather is colored, but it appears different colors to different observers, right, depending on the angle of incidence. On some accounts of color, that's a subjective phenomenon. On other accounts of color, it has to do with objective spectral reflectance rays. But in any case, relative to those kinds of circumstances, right, then we can say that the feather is blue, but only relative to the proper circumstance. We can't just pick out one of those circumstances and say, oh, the feather's really red because this is my favorite circumstance. Both of those circumstances are, whatever they are, red or blue, they're equally good. And importantly, notice that, you and I could both be looking at the feather at the same time. So that is what I call multiple relativized determination. And that explains how you could have an entity have a determinable property, like having a certain life status, going from the emitter to the detector, or being some kind of botanical entity, and then have the determinations, incompatible determinations of that determinable property be in some sense instantiated, but only relativized, right, to some subjective or objective circumstances. Of course, there's a lot more. I'll just finish by saying, I think, given these commonalities, if you can work out the details, I think there's actually a huge payoff, maybe not so much for physics or for Buddhist studies, but definitely for metaphysics. Because in metaphysics, we're really hungry for these kinds of case studies. And we're also, I think, this is really a very fertile time in thinking about indeterminacy. And as it turns out, and actually I think we're going to I'm going to be especially looking closely at Ho's arguments in particular, that given this approach to metaphysical indeterminacy in the Chinese Madhyamaka tradition, you can make sense of certain things that contemporary metaphysicians are very, very commonly thought to not make any sense at all, such as indeterminate identity, indeterminate existence, indeterminate change, right? So I think that's, for my money, for me personally, and I think for some of my fellow metaphysicians, could be really a potential huge payoff. So hopefully the similarity here is something that sounds consonant to both the physicists and the Buddhist scholars, and thank you for your attention.
I was hoping that Francesca had a question.
Thanks very much for a really rich paper. And you caught me by surprise at the end.
Okay.
So I want to explore that little surprise at the end.
Okay.
Because for a while I was thinking, oh, sorry. Should I say all that again? For a while I was thinking, yeah, this is going to be a great metaphysical argument for paraconsistency.
Yeah.
And then you backed off.
That's
and
right.
In particular, I was wondering about that because of Jisung. In a study that Bob and I and a couple of other people, Grant Priest and Yasuo Taguchi, published earlier in the year, we really argue that Jisung, for different parts of his philosophy, because of the hierarchy, right?
Okay.
Is pretty much committed to paradox.
Okay.
And that he's a good old paraconsistent guy.
Okay.
And this isn't an objection, it's just a question.
Yeah.
Why don't you follow Jisung into paraconsistency?
It may be contingent that I have, sort of aim to understand indeterminacy in terms that were compatible with denial of paraconsistency and, moreover, acceptance of classical logic in full force. That, in a way, reflects that I'm trying to get people to take it seriously. I know, sorry. No, and, it's very, look, the sociology of philosophy, and as I'm perhaps in other areas as well, it's something to be delicately maneuvered or, accommodated. But I think it would be interesting, and I'd love to hear more about, the argument to the effect that the considerations of the sort, for example, that Ho was leveling, did commit to a non-relational understanding of what was going on. Now, if that were the case, then I think Ho himself, I would like to see what he has to say about that. I don't think he thinks that that's requisite. So it might be that there are interpretive options, at least at a certain level of abstraction from some of these doctrines, where you could go one way or the other, and then one could pursue that avenue. So it's not because I feel like no sense could be made of this. I'm just, I guess, in a way, sort of theoretically conservative. I hate to say that word, but
Could I follow up just for a second?
yeah,
All I wanted to say is that if you look at more of Jisung,
yeah,
you see that whether correctly or incorrectly,
yeah.
Jisung is inclined towards paraconsistency. And so for the very
Right,
reasons
good, yeah,
that you suggest taking it seriously, I like to take it seriously.
yeah,
In
yeah.
that direction. And once you go paraconsistent, once you take that plunge,
yeah. I'll never go back. Thank you.
Yeah, thanks for this talk. I'm wondering whether this objects level definition of indeterminacy can is a different category and can't be applied properly in interpreting the kind of indeterminacy that's going on in the quantum level. And my reason for worrying about this is that it seems like this object level indeterminacy that's defined within this Buddhist tradition, I'm assuming it probably depends upon some sort of contrast between conventional reality and ultimate reality. And it seems like so the very concept itself, it's based in the fact that in our conventional reality, our sense of reality, we have to categorize things to make sense of things, but we can imagine things in themselves, without, and imagine that things in themselves don't have any of these concepts that we attribute to them inherently. So there's always multiple different kinds of experiences that possibly could be underpinned by the same mind independent phenomena, or the same mind independent phenomena could give rise to a plurality of different human experiences, for example. So it seems this objectal indeterminacy depends upon this apparent kind of contrast between a mind independent world and humanly perceived world. Maybe I don't know, I may have couched in some language that's too strong, but
Yeah.
Hopefully I'm conveying that idea at least vaguely. But then I guess what I'm guessing quantum physicists, when they talk about the indeterminacy of the location of a particle, the double slit experiment, for example, they're thinking about just the mind world in itself, and it just seems strange to me. It seems almost like a category error to try to impose a definition of indeterminacy that relies upon this contrast or juxtaposition between a human world and a mind-dependent world. It seems that, aside from that, and apply this kind of concept into a domain that purports to talk about the mind-dependent world itself. But maybe I'm also misrepresenting what physicists actually believe about what they mean by indeterminacy, because I haven't talked to quantum physicists, so maybe I'm just misconstruing things. But
Yeah, well, thanks for that question. I have been trying to remain studiously neutral about, what the ultimate status of these determinables and determinants are. So I don't think it's built into the notion of an object level approach that the determinants that are, at least a glutty implementation of an object level approach, that somehow, when an object has a given determinable, then the determinate values themselves are somehow necessarily mind independent, maybe they are. I think this is just a further question. And I was also trying to be, really as unprincipledly neutral as possible as regards what the circumstances to which relativization would occur in cases of multiple relativized determination, whether that would, for example, involve some irreducibly conceptual or mind-involving element, as on, say, for example, some subjectivist accounts of color, right, in the treatment of the feather, or if it might be cashed out in purely, some kind of terms that just have to do with worldly goings-on, right, if we're talking about spectral reflectance properties. But one of the things I'm interested in trying to find out, and I'm sort of, extracting a little bit from what Carlo and Jay were saying too, is that there's, it's not clear that there's a sharp distinction here. It's not like the Buddhists are saying, oh yeah, if there were no minds, everything would be determinate and have intrinsic nature. It's not just a matter of our involvement, but the possibility of multiple relativized determination, for example, in the case of the feather, Schrödinger's cat, or the daffodil, it seems to me, would all be potentially such as to occupy a single space, right, whatever that space is. Yeah, I don't know if that's completely helpful, but basically I'm just saying, so far as I know, there's no specific commitment to a duality of, right, convention versus convention independence that's built into the approach, I hope.
Well, I'm not sure.
Okay, all right, let's hear more.
I also don't know enough about Jizang. It's been a long
Yeah.
time since I've looked at Jizang. I'm not a fan of paraconsistency as an interpretation of Buddhist texts. But one question I would have, like the way Ho describes, so I'm just going to maybe probe a couple of things real quick here. So in terms of like Ho's paragraph on the daffodil, that doesn't sound like just that paragraph is not saying that the other determinations are going to be incompatible with daffodil, right? Just
That's true. Not at the level of relational.
Right. So at the same level of
attribution.
analysis, or from same modality or perspective, whatever term you want to use.
Yeah.
Is he saying that there are incompatible determinations, like this is both a daffodil and something which is incompatible with daffodil at the same level of analysis?
Yes, he is. So later in his paper, I didn't go, this adverts to the stuff I was talking about at the very end when he was talking about indeterminate existence. So that would be a case in point where, for example, he used the case of a 6-month-old fetus, right, who is, provisionally determined as being the same as the child that is eventually born, provisionally determined as not being the same, provisionally determined as being partly the one, partly the same, partly not the same, and so on. So that would be a case where at least some of the determinations will, properly understood, all of them are mutually inconsistent.
Sounds in some ways as just a sort of indeterminate case, whereas a daffodil is in a more straightforward way, doesn't seem to have that kind of indeterminacy built into the example, right? Because we're talking about the future of the child. So I'm just wondering whether Jizang
whether the child exists at a certain time, who the indeterminate exists, or the identity of the child, the identity of this object as a daffodil. If in fact it can be determined as something that is like not a botanical object, then you can get an inconsistency going.
So part of the reason I'm asking is just what I see here so far is very compatible with in Indian Buddhism, a position around ineffability.
Ineffability.
That does not, which has a metaphysical component, which is essentially a very strong form of nominalism. So entities universals don't exist. Entities don't bear properties in which universals somehow inhere.
Yeah.
So they can have multiple descriptions, and none of those descriptions determine what the thing is in itself.
But they're not incompatible necessarily.
They can be. So here's the thing.
Okay.
They can be incompatible depending on what kind of a life world you're embedding that object in. So that's the usual example, that you have a kind of, first of all, you have a type of indeterminacy which is really maybe epistemic for you and has a metaphysical component because it's got claims about whether objects can bear universals, which they can't. Their only particulars exist.
Yeah, good.
So you can't exhaust the object with a description.
Yeah.
And then those descriptions are perceiver dependent. Yeah. And so depending upon the makeup, the life world of those perceivers, you end up with contradictory predicates. So I mean that's the way it's usually done in Indian Buddhism. And I'm just wondering
good.
whether that's what's going on in Jizang or not?
Well, yeah, good. They're the experts over there, but just in terms of, you know, how I would sort of incorporate your question into future work on this topic, I think you're raising a very interesting question about, you know, would any relativized determination necessarily be one which would have, you know, induce indeterminacy of this form? So it might not be the case. So if I, for example, relative to a certain perspective, it's a daffodil. Relative to another, maybe I'm doing material science, it's a material object. Relative, you know, that it's not really incompatible there, right? Even without relativizing, you could say, oh yeah, it's a daffodil and it's also a material object, right? So it may be that some of these determinations are not mutually incompatible. So yeah, I guess that's right. I will just take that point. But sufficient numbers of them are, and perhaps, you know, we can kind of cook up, sufficient numbers of them are incompatible on the face of it, you know, like something that would entail that it was not a daffodil on a different relativization. But, yeah, sorry. I distracted myself.
Can I just follow on top of that?
Yeah.
Because I also had some of the same worries that John had, but we can talk about that after. It has to do with how to interpret Jizang.
Yeah, okay.
In brief, I think what John is, the way I would frame it is there's really no way, insofar as these guys are Madhyamikas,
Yeah.
The Chinese, that the notion of a mind-independent reality makes any sense to them.
Yeah.
Now, it's certainly all relational, but it's relational to sentience. And so when you get into superposition talk, I'm not sure that translates into, it would translate into other kinds of Buddhism, but not the kinds of Buddhism that you're talking here.
Yeah.
But that's a little quibble. I just wanted to ask you one meta question, because we only have a couple questions left. But what is Chinese Madhyamaka doing for you in this discussion, which I think is important in terms of the kind of larger conversation we're having here? I mean, what are they bringing to your work or to this picture?
I want to answer both questions. So the first question having to do with the potential, I think this also is adverting to your question in the back there. You know, there might be aspects of conceptual or sort of conventional, mind-dependent sort of factors going on, right, in the Madhyamaka tradition that may or, you know, are usually not understood to be operative in these other, in the quantum cases. But for me, that's why I was careful, or I tried to be careful, to say that the similarity I saw was structural, right, involved, you know, the having of a determinable property and then there being these multiple seemingly incompatible determinations while remaining neutral on the exact status of what those were, you know, or what you know, what forced the presence of that structure or what the content of the properties that were associated with that structure actually were. So, for what it's worth, you know, so there can be similarities without it being similarity all the way down, that's for sure. As far as what I've been getting out of this, well, I mentioned a couple of things, and maybe as I'll rehearse those and see if I can think of anything else. But like, first of all, I think it's just a great case in point, a potential case in point. So even if we can also understand what's going on in the Chinese Madhyamaka tradition as not necessarily committed to metaphysical indeterminacy of this structural variety, but rather as advocating for something else, so long as there's a reading of it that is friendly to this interpretation, and I do at least have one person who is on record as saying that this is their preferred interpretation, and you know, so that's enough to get the ball up and rolling for my purposes of saying, and it's not just quantum mechanics, but also, you know, at least certain readings of Chinese Madhyamaka that could support a kind of metaphysical indeterminacy that has the following structure. I should clarify too that on some interpretations of quantum mechanics, there is no metaphysical indeterminacy, right? So there's ways of understanding what's going on. David Glick, for example, has an alternative way of thinking about what's going on that doesn't involve indeterminacy. So there's, for any given area of theoretical investigation, there's going to be more than one reading. For my purpose, what's mainly important is that there's at least one reading in the Buddhist tradition that seems to indicate a kind of interesting metaphysical indeterminacy of the sort that my account in particular is suited to handle. It bears interesting structural similarities to quantum metaphysical indeterminacy, on some readings, and as some people have thought it should be handled. And then second, I'm really interested in these questions about indeterminate existence and identity. I haven't done that work yet, but I think that's where I would like to go next with it, as inspiring the possibility that there could be such a thing. And if there could be really, if you can make sense of indeterminate existence and identity, wow, all bets are off. And there's going to be a whole lot of more work for me to do.
All right, thank you.
Thank you.
Okay, thank you everybody for coming back. It's now time to leave the floor to Chris Fuchs, and directly after the question to Chris, we will have also the intervention of Price online. So, thank you, Chris.
This is going to be a particularly cruel talk, being as it is the end of the day, and perhaps the most physicsy of the talks that you'll get in the next 3 days. We'll see whether it is or not. I have at least tried to entertain you with some artwork, even if the equations aren't so inspiring necessarily. It's pretty difficult to look on the internet and find pictures of the Buddha in Cubist style. I searched and I searched and I searched, and these are the only two that I was able to find. This is called the Meditation, and this one, not surprisingly, is called Cubist Buddha. So I'm going to talk about a point of view called QBism that colleagues and I have developed over the years. Q stands for quantum. B initially stood for Bayesian, because we tried to insert a Bayesian notion of probability into our understanding of quantum mechanics. You can see that we were all younger when we started this work. I was particularly young. Now, we caused no amount of troubles for ourselves by calling ourselves quantum Bayesian, because we didn't realize how large the Bayesian community was. And just like apparently with Buddhism, there are so many schools within Bayesianism that 99% of the Bayesians would come up to us and say, look, you're no Bayesian. You're too radical to be a Bayesian, because there was a particular variety of Bayesianism that we had in mind when we adopted the word. So ultimately, the idea that QBism was quantum Bayesianism fell by the wayside. Somewhere around 4, 5, 6 years ago, I came across some writings of a Supreme Court Justice, Oliver Wendell Holmes Jr., who in a 1929 letter to one of his friends said this little quote that actually goes so much more closely toward capturing what QBism is. I've decided, despite the ugliness of quantum betabilitarianism, it's worth it for the clarity. So Mr. Holmes said, Chauncey Wright, a nearly forgotten philosopher, and I would challenge, how many of you have ever heard of Chauncey Wright? Okay.
He taught at Smith.
He taught at Smith. Lovely. Chauncey Wright, a nearly forgotten philosopher of real merit, taught me when young that I must not say necessary about the universe, that we don't know whether anything is necessary or not. So I describe myself as a betabilitarian. I believe that we can bet on the behavior of the universe in its contact with us. And the word contact is important here. Now, what am I doing at this meeting? I'll just admit right now that I was influenced by the early American pragmatists and essentially no one else in philosophy. So I have lots of philosophical friends like Hugh Price, who calls himself a pragmatist, but just like the Bayesians said, oh, you're too radical of a Bayesian for us. I tell Q, well, you're really not enough of a pragmatist. But I was influenced by the early American pragmatists, and by all rights, I don't think that I should be here. But Bob Sharf wrote me somewhere in 2020. He said, when you say you are committed to, quote, experience that is neither internal nor external, but something shared across the two, and in fact more fundamental than either, that is precisely why some folks in Buddhism, myself included, are so interested in QBism. Now, all I was doing was channeling William James with that quote, so perhaps it should have been James that was invited. But QBism does have a lot to do with early American pragmatism, and I don't know, maybe you'll see some of the roots here. So I decided that I would come and talk in front of you guys, despite knowing not a thing about Buddhism. I thought, well, if I'm going to talk in front of Buddhists, I should present an eightfold path of our own. So QBism, and actually I had a paper where I had a list of 8 things that defined QBism, and I took this straight out of there. A quantum state is an agent's personal judgment. A quantum measurement is an agent's action upon the external world. So in QBism, the metaphor of an observation, well, we don't even use that word, is not the metaphor of an eye, but rather the metaphor of a hand taking an action on the world and seeing what the world gives you in response. Measurement outcomes are the agent's lived experience. That's something that we'll come across by the end of the talk when I'm not saying so much about what QBism says to Buddhism, but what can Buddhism tell QBism for how to proceed. Anyway, I'd like to give you some flavor of some of these things, and I'm going to go down, I'm going to start, you might say, at the technical. QBism is not something that was just born out of a scallop shell like Venus, but rather started with a technical development. And the technical development has led it in directions that weren't perceived initially. If I had to give a metaphor for what QBism is, I think the best thing that I can do is exhibit this book by Leonard Jimmy Savage. Jimmy Savage's friends called him Jimmy, called The Foundations of Statistics. What's significant about the book, and I have a copy here though without the cover, is that it was the first development of decision theory. How to make better decisions, how to gamble if you must. That's what the book is about. Now, why do I think that this is a good metaphor for QBism? QBism is an interpretation of quantum mechanics, say. Let's start with that premise. QBism is an interpretation of quantum mechanics. I want to compare that interpretation of quantum mechanics to a book on decision theory. So I just kind of imagined myself walking into a bookstore one day, finding this on the shelf, and Savage lays out the postulates that he's going to use. He introduces the notion of utilities and how to make decisions and so forth. And I start reading it, and I think, boy, this is a pretty good way to proceed for making better decisions. So if I learn enough of it, I'll be able to make better decisions. I tell a friend about this. And I say, aren't you interested in this book for making better decisions? And I imagine the friend goes, no, I'm not interested. And why not? Well, the book doesn't tell me what exactly it takes to be a user of the book. It doesn't describe what chemical composition is necessary to be able to be a user of the book. This is what QBism hears all the time. You've got to tell me what an agent is, people say. You've got to tell me what an agent is before this interpretation even makes sense. Well, does the idea of the user of a decision theory book make sense without defining in detail what the user of it is? Yes, it does. Similarly, I might imagine if I got this past the friend of mine, he says, well, look, by using that book, you think you're superior than me. You think that you're outside of the system. I'm like, no, I'm not. Here, you can take the book and use it yourself. Similarly with QBism, it's an interpretation of quantum mechanics that I can use to make better decisions, and you can use to make better decisions. It makes you a solipsist. You're a solipsist because you're only worried about your own decisions. Again, I say you take the book, you can make your own decisions. I'm not a solipsist. In fact, we're talking to each other. So anyway, this is why I think that this is a good metaphor. Let me give you some sense of what the whole point of view is about by first discussing the Bayesian notion of probability that QBism uses. This goes back to a man named Bruno Divinity. Diviniti's paradigm is egocentric. This is something that someone wrote about him. It is a tale of a single person contemplating the world and not wanting to be stupid. He realized that to do this, his statements of uncertainties must satisfy the laws of probability. So this is the key idea behind this version of Bayesianism. It's about not being stupid. How do you formalize that? Well, the way it's formalized, at least in Divinity's development, is through an argument called the Dutch book argument for giving definition to probability. So the primitive concept that's at play here is that one is interested in buying and selling lottery tickets. A lottery ticket that, for instance, is worth $1 if the event E occurs. So you pay a certain amount for it, and the bookie has certain numbers published. He says, I'm willing to buy a ticket, this ticket, for anything less than piece of B, and I'm willing to sell it for anything more than piece of B. Any epsilon less, any epsilon more. So it's about pricing. Now, what does that have to do with probability theory? Probability theory is a big, complicated mathematical structure. The thing that Divinity noticed is if you add to that notion of pricing a normative rule, namely that the bookie should never declare numbers on his price board that will lead to a sure loss, then it has to be the case that these numbers have to satisfy the axioms of probability theory. So you can imagine someone coming up to the desk and saying, I want to buy some of those tickets, I want to sell some of these tickets, and so forth. And if the numbers are not adjusted to satisfying the rules of probability theory, then someone can walk up to the bookie and make sure that they make positive money no matter what happens. So the origin of probability theory from this point of view is in normativity. It's something that you satisfy so that you don't put yourself in a bad position. Now, why a normative reading? In the real world, it's really difficult to come up with probabilities. So in your textbooks, you're given, like, suppose this and suppose that, now derive the probability for this. In the real world, it never happens that way. You might, for instance, get your long-term weather reports from the Washington Post, and you might get your daily weather reports from the New York Times, and you might look up some various statistics from the Austin American-Statesman, and to get at these various probability assignments. Now, given that these come from different sources, they may not satisfy this equation. What the normative reading says is you had better find numbers that do satisfy that equation, or you're in trouble. So in this sense, the valuations are subjective. And in particular, it may be the case that you have to bang them a little bit to make them fit the equation. So to some extent, there's always an element of what William James called the will to believe in a probability assignment. So all the terms in this relation, from this point of view, are subjective. They're not objective states of affairs in nature. But not everything is subjective. Particularly, the normative relation is not subjective. If you don't satisfy it, you're putting yourself in harm's way. It's the norm that is agent independent. Well, QBism wants to see quantum theory in the same sort of light. QBism views quantum theory as supplying extra normative rules to probability theory, extra ones, not different ones. So let me pick up the book again. Imagine that Jimmy Savage, wrote a second edition, and in the second edition he added some appendices. One, for instance, is making decisions in love and marriage. Well, you can easily imagine that maybe some extra assumptions are needed for making refined decisions in love and marriage. So you've got the whole structure that you had before, and to that you add extra normative rules for the given subject matter. There may be another appendix that says making decisions in light of interacting with the external world of some variety. And the idea here is that that's what quantum mechanics is about. Extra normative rules that we have because we live in a world of a certain variety. Is there any solipsism in this? No, there isn't, because we're admitting that we live in a world, that we're in the middle of it, and we have to be making decisions. Is there idealism in this? No, there's no idealism in this. It just says quantum theory is a user's manual. You've been messed up if you think that quantum theory is a direct description of all that is. That's the kind of idea that's going on here. So, given that motivation, we QBists have to try our best to understand the various equations in quantum theory in purely probabilistic terms so that we can fit it into the same book that Jimmy Savage wrote. For instance, the Born rule that is usually read as saying, given a quantum state, that's what this symbol is, and given a measurement operator, we can calculate the probabilities of the outcomes of the measurement according to this formula. Now, in a normal reading of that, a normal presentation, these things on the right look like they have a metaphysically different status than the thing on the left. This is a property of a system in some interpretations. This is a property of a measuring device in some interpretations. Property combined gives probabilities, and now these Bayesians, these QBists, want to say that the probabilities are gambling commitments. So somehow we're getting gambling commitments out of objective states of affairs, and the QBists don't want that. So we have to work hard to find a way of understanding this in a way that only uses probabilities and doesn't have something of a metaphysically different status. Same thing goes for the Schrödinger equation. I'm not going to talk about the Schrödinger equation in this talk, but everything that I do for the Born rule can be done for the Schrödinger equation as well. You can get a little guidance from a paper by Richard Feynman in 1951 titled The Concept of Probability in Quantum Mechanics. Feynman said, the new theory asserts that there are experiments for which the exact outcome is fundamentally unpredictable, and that in these cases one has to be satisfied with computing probabilities of various outcomes. But far more fundamental was the discovery that in nature the laws of combining probabilities were not those of the classical probability theory of Laplace. So he thought, oh, it's neat or strange that you are forced to use probabilities. But that's not really the surprising thing. What's surprising is that the laws for combining probabilities are different than what was expected previously. Now, what he had in mind, of course, was the famous double slit experiment that he wrote in his 1964 textbook, or maybe it was a 1964 lecture. We choose to examine a phenomenon which has in it the heart of quantum mechanics. In reality, it contains the only mystery. But when he settles the issue, he ends up doing it by introducing complex numbers, complex amplitudes, and moving away from the probability concept to begin with. So in comparison to what he says over here, he says the rules for combining probabilities are not those of the classical probability theory. And then by the time he gets here, he just drops probabilities, and ends up saying the more fundamental thing are complex amplitudes. Well, this throws philosophers off. I'll give Harvey Brown as an example. So what I just said before was that that's extraneous. It gets in the way. Here's a quote of Harvey. Powerful plausibility arguments have long been available, some since the birth of quantum mechanics, to the effect that the quantum state is something real. They almost all have to do in one way or another with quantum phase, with the fact that the wave function in its relation to probability is strictly a generally complex probability amplitude. It has more structure than a probability distribution does. And that's the impression, of course, that one gets by taking this route of solution. But of course, I'm going to say, I shouldn't say of course, that's just wrong. It's just wrong. It's a remnant of a particular representation, the one representation that most philosophers of science are taught about, have been taught. A physicist, on the other hand, maybe not all physicists, but some physicists, tinker with the formalism constantly until they find a way of expressing the formalism that doesn't make it look like what you were taught in the classroom. And that's what I'm going to show you here. I'm going to show you a different representation of quantum theory that gets rid of complex numbers altogether. It's completely equivalent to normal quantum theory. It has nothing more in it and nothing less in it than normal quantum theory, but it doesn't use complex numbers. And it gives you a different way of thinking about things. The way I'm going to do it is, and I can't tell you too many details, but basically I'm going to take the Feynman idea of looking at the double slit experiment and generalizing it with some of the tools from quantum information theory and quantum computing, which is my bread and butter field, and then show you how it gives you something different. So here the setup is, I have a quantum system, and like Carlo said in his talk, a quantum system can be anything. So it can be an electron, it can be an atom, it can be a complex molecule, it can be a person, it can be Carlo himself. A good complex quantum system. But I'm going to be in the setting where we have finite dimensional quantum systems. So you've heard of qubits, that's a 2-level system. Q-trits, that's a 3-level system. In general, I'll be talking about Q-dits. These are D-level systems. And what we have is, in place of the screen, we've got a general quantum measuring device over here. And in place of a detector at the slits, we've got a very special kind of device that we didn't know about until we learned enough quantum information theory in the 1990s. This is going to be something called an informationally complete measurement, a minimal one. And this will be just any general quantum measurement over here. Notice what I've written down here. I've written down the quantum state there. And I've written down a description of the measuring device here and the probabilities for the outcomes of it. Similarly, I've written down a description of the measuring device here with the probabilities for the outcomes of that measuring device. But I've also written down the conditional probabilities of these outcomes given these outcomes. And notice finally that I've equipped this one with a switch. I can turn it on or I can turn it off. So that is like in the double slit experiment having detectors at the slits or taking them away. If I turn it off, it's like taking the detectors from the slits away. If I turn it on, it's like putting the detectors there. Okay, now I want to play a following game. So I've told you the whole setup in terms of quantum mechanics, but I want to take a magic eraser now and erase the quantum mechanical origin of this. So I take away the quantum state. I take away these measurement operators. I take away these quantum states. And the only thing I leave behind in my description are the probabilities. So this is the picture. The switch is turned on, but I've taken away all of the details of this measuring device and all the details of this measuring device. And the only thing that I've left in the story are the various probabilities. Can we say how these probabilities should be related? No one's going to vote. But how many think that you can say that we should be able to say? Adam says yes. Yes, because Adam is a true Bayesian, and he says, well, look, it's just given by the law of total probability. There's a Dutch book argument that tells you how the probabilities have to be related. It doesn't matter whether they come from quantum mechanics or whether they don't. If you don't satisfy this equation, then a bookie can take you to the cleaners. Okay, I'm going to get in the habit of writing this complicated looking equation just in shorthand form like this.
Why is that wrong?
Sorry?
Why is that wrong? Why is right?
Why is what?
So this is not killed by interference. That's what you say.
It has nothing to do with quantum mechanics. It has to do with having probabilities. So you've got these various probabilities in the story, and if they don't fit together, and some bookie has published these numbers, if they didn't satisfy this, then you could say, I'll buy some of those tickets, and I'll sell you some of these tickets, and I'll buy some of those tickets, and then no matter what happens in these two measurements, he'll lose money. Okay, that's with the switch on. What happens if we turn the switch off? If we turn the switch off, now the Born rule is our guidance. The usual quantum mechanical law has to be our guidance. There aren't any probabilities in the stories anymore except for this final one down here. So this is like taking the detector away from the slits, and now we've got probabilities for various outcomes. So it looks like we've got a completely different beast now, because this isn't the relation between probabilities, it's a relation between these quantum states. These take complex numbers, they got to be written in terms of matrices, and we got probabilities on the left. Well, I say it's not a relation between probabilities, or is it? And you go, dum, dum, dum. It is, in the end, after all, a relation between the probabilities. If you do just a simple calculation based on the properties of this informationally complete measurement, you can write the Born rule probabilities in terms of the probabilities in the other experiment. Probabilities in one experiment can be written in terms of probabilities in the other experiment, and it almost looks like the law of total probability. Remember what the law of total probability looked like? It looked like this. It was a probability on the left is equal to a product of two probabilities. The only difference is now the probability on the left is equal to the product of two probabilities with something in between. It works for any quantum measurement whatsoever. It's not like Feynman's double slit experiment where he only had this screen at the end of the day. There are no operators in this equation. There are no state vectors. There are no complex numbers. And yet it is mathematically equivalent to normal quantum theory. Is it inconsistent in some way with the usual laws of probability? Well, no, it's not. Because these numbers, which have to satisfy the laws of total probability, are for one experiment, the switch-on experiment. The probability on the left is for a completely different experiment. So from this point of view, what you see is that the role of quantum mechanics is to glue the probabilities in two different experiments together. And if you're talking about measurements in the regular world, if you don't satisfy these laws, you're in trouble. So in QBism, we want to give a normative reading to this. Normative reading then requires that, well, there's some of William James's will to believe, perhaps in this term, and in that term, and in that term. To that extent, these are subjective ascriptions. But overall, the relation is an objective feature. We adopt this particular relation because we're doing it in light of the world that we live in. So this is the first hint of some depth. The sole difference between switch on and switch off normative guidance is that this matrix that appears in this equation is not the identity. That contains the essence of quantum theory. If you characterize those matrices phi, you've characterized quantum theory. Now, looks like a trivial little change. Well, no, it's not a trivial change. It's enough to change a whole worldview. And that comes about when you ask the question, well, what are these probabilities about? You got probabilities. These are things you're gambling on. But what the hell is it that you're gambling on? Are you gambling on things that are pre-existent but unknown? This option was brought up as one possibility in Jessica's talk. Or you're gambling on things that, quote unquote, come about. Well, now you've got the quantum mechanical formalism understood in normative terms, and it turns out these normative rules lead you, if you're open to the possibility of being led, not like the Bohmians say, if you're open to the possibility of being led by physical facts and the physical formalism, They lead you to a different understanding, perhaps, of what's going on. And I would argue that they settle for this rather than that. Let's go to the EPR criterion of reality. Everybody knows that they famously said in 1935, Einstein, Podolsky, and Rosen, that is, if without in any way disturbing a system, oh, by the way, that picture is accurate of Einstein in 1935. He looked like that in 1935. What the other two looked like, I don't know. If without in any way disturbing a system, we can predict with certainty, there's that word, certainty, i.e. with probability equal to unity, the value of a physical quantity, then there exists an element of reality corresponding to that quantity. Certainty without disturbance tells you about the existence of an element of reality. Let's think about how a QBist would think of this. Well, they go back to the notion of probability as defined by the Dutch book, and they ask, well, what means probability 1? Well, by the framework there, it means that an agent will buy or sell a lottery ticket worth $1 for, in fact, $1. Full stop. That's all it means. Probability 1 does not in any way imply truth or existence from this point of view. It's about how someone will gamble. Richard Jeffrey said it very nicely when he discovered this before me, and I found this quote years later. The Bayesian framework replaces affirmation and denial by a continuum of judgmental probabilities in the intervals 0 to 1, endpoints included. 0 and 1 are probabilities no less than 1/2 and 99 100ths are. Probability 1 corresponds to infinite odds, 1 to 0. That's a reason for thinking in terms of odds, to remember how momentous it may be to assign probability 1 to a hypothesis. It means you would stake your all on it, but there's no implication that it means that the hypothesis is metaphysically true. So, let's go back to EPR. Let me use Tim Maudlin as a foil. If I could make one change to the EPR paper, it would be to alter the characterization of this criterion. The authors, Einstein, Podolsky, and Rosen, call it reasonable and, quote, in agreement with classical as well as quantum mechanical ideas of reality. But its status is much stronger than that. The criterion is, in the parlance of philosophers, analytic. This criterion follows just from the very meanings of the words used in it. Not so for QBism. The words mean different things, apparently, in QBism than they do in whatever philosophy Tim Maudlin is following. So the main point here is that this breaks the mystic hold of the EPR reality criterion, for a QBist at least. Now the quantum formalism does all the rest through the theorems of Bell, Cushion, and Specker, even Pusey, Barrett, and Rudolph, who thought their theorem proved something different than I think it proves. So from the point of view of QBism, now I'm going to be, so now all of you guys who didn't want the equations, you can relax. Now it's going to be more vague, and then I'm going to finish up pretty soon. From the point of view of QBism, the great lesson of John Bell wasn't that nature is non-local. One should think about the Bell theorem as saying, well, nature can either be local, or when we perform quantum measurements, they're not finding pre-existent realities. If you hold on to the idea of locality, and QBists have reasons that I can't get to in this time limit of this talk, hold on to locality, then it tells you that it has to be that there aren't pre-existent things that are being found by quantum measurements. So it's not that nature is non-local, it's that nature is creative. And for just a little poetry, here's something I put in a paper. With every quantum measurement, the world is shaped just a little in a new moment of creation. Those moments of creation, sought out or noticed, where an agent hitches a ride. So the point of view here is the phenomena is all around us. The world is still in creation. The Big Bang didn't happen in the remote past. It's something that's happening right here, right now, and we're part of it. We're right in the middle of it. But we only pay attention to some of those things. We pay attention to those things like, when I push on this desk, I expect a certain reaction. I felt it on my fingers. Those are moments of creation, part of this bigger Big Bang. But they're ones I pay attention to, and they're ones that I might gamble on. And it's only when I might gamble on something that quantum theory comes into the story. Quantum theory is not a picture of what is exactly happening in the world. It's a picture of, it's not even a picture. It's something I use, it's like that manual down there, when I want to make better decisions. So in my eightfold path, fold number 2 and number 3 amount to this. A quantum measurement is any action an agent takes upon the world. So look, didn't cost me $1 million to do it. I just made a quantum measurement. I took an action on the world. And its outcome just is the consequent personal experience it induces in me. Particularly, quantum measurement outcomes are not, to paraphrase Bohr, instances of irreversible amplification objectively recorded. Bohr actually wrote like this. They're not instances of, quote, irreversible amplification objectively recorded for everyone to see in a device whose design is communicable in common language, suitably refined by the terminology of classical physics. For me, a measuring device is not something, that's big and bolted to the table. A measuring device is me. So I said an action is anything. Well, here's an action. I was at L'Étoile once, and there was this crazy woman beside me, and she said, I think I could make it. And she ran across, and she survived, thank God. Did she use probability theory when she made her decision? No, she didn't. Would it have been better for her to use probability theory before making that decision? Well, maybe or maybe not. It depends upon how much time you have to make your decision. In the heat of the moment, in fact, if something's chasing you and you've got to get away, you don't have time to use probability theory. You just use your intuitions. But if you've got time to, sit around and decide what you're going to do, then it might be to your benefit to use probability theory. There's no necessity of using probability theory. It can just help you. And there are some sophisticated situations, like in this laboratory, where it actually pays you to use more than probability theory. It pays you to open up Savage's book, go to the appendix where it says extra assumptions available for when talking about interacting with your external world, and then it might be useful. Okay, so that's the point of view, that quantum measurements are happening all the time, but we're not always using the quantum formalism. The quantum formalism is about making better gambles. One thing that's crucial to this point of view that is implicit in this X through Bohr's classical devices is that within QBism, conceptually the lab equipment is part of the agent. Just like my glasses here are extensions of me, and I don't think of them as anything separate. They're aids to my taking actions on the world. Similarly, the lab equipment. Now, why are we pushed in this direction? And I'm almost to the point of saying something about Buddhism. Bohr said the outcomes are available for all to see. QBism rejects that. And the reason it rejects that is because of considerations to do with Wigner and his friend, which I'm not going to go into great detail about, but that is part of the story that forces us to this radical conception that the laboratory equipment is part of the agent, just like my glasses, are essentially part of me. But I now want to riff on this just a little bit. Let's stick with Wigner and his friend and think about the symmetry of this situation. So here's, I think, a fundamental difference between, Carlo and I have a lot in common in some pieces of quantum theory, in our different views of quantum theory. Carlo wants to start out, if I understand you correctly, pushing all of the epistemics business to the side and talk about what's going on in the world. QBism wants to start with the epistemic stuff, because we understand quantum theory as this manual that we use. But nonetheless, you can put yourself in situations where now a certain kind of commonality, I think, comes out between us. You start at the non-epistemic end, I'm going to start at the epistemic end. So starting at the epistemic end, consider the symmetry of this situation. By the way, you guys know who these are? Well, this is Wigner. I already revealed that. Someone said it. Heisenberg. So Heisenberg was Wigner's friend. Think about the symmetry of the situation. Now, the way I've drawn it, Wigner is the agent. He's the user of quantum theory. And Heisenberg is a system that he might be willing to gamble on. So if you noticed, it looks like Wigner and Heisenberg are making some kind of exchange there. I put a little spark in my picture. This is the tingly bit that happens, in part of the experience. But like I say, this is a completely symmetrical situation. If he is the agent using quantum theory, then he treats this as his system. But remember, I can hand the book to anybody because this isn't about solipsism. It's not about idealism. So let me hand the book to Heisenberg. Now Heisenberg is the user of quantum theory as a decision theory, and Wigner is his system. And there's the tingly bit going on there. You might ask, well, what is all of this from the God's eye point of view? QBism rejects. Oh, there's no wall here. QBism rejects there being any God's eye point of view. So we can't say, oh, one of these is the super observer and one of them isn't. That doesn't make sense from the point of view of quantum theory as a user's manual. So there's no God's eye point of view. Well, I think that this is telling us something. In both pictures, even though we have different uses of quantum theory, in this case, we've got his use of quantum theory and he's a system. We've still got the tingly bit going on, regardless of it. And I think there's something to be learned there. We as physicists want to say something about what reality is. So that's where Carlo and I are actually on board. Though Carlo didn't know it at times. We're on board on this. We as physicists want to say, oh, well, we hypothesize that the world has this character, that the world has this going on. What is it that the world has going on? I think that this point of view suggests that trying to abstract this element, the tingly bit, or as Whitehead called it, the throbs of experience, is really the stuff of the world. And taking the point of view of quantum theory as a user's manual is kind of a back door into exploring that idea and exploring it with some precise new mathematics. How many of you knew that you could write quantum theory without complex numbers? 1, 2. Yeah, this is new to most people, strangely. All right, why I'm at this conference, I showed you what QBism says to Buddhism as Bob wanted me to. Well, why I'm really here is to figure out what Buddhism can tell QBism and what pictures it can put in these two places with the help of all of you. Thank you.
Hi. So you found the slide experiment that quantiles don't follow Laplace's. And exactly how is that?
Well, it depends upon your interpretation. Oh, this is what Feynman said. I would say, well, it did. So in the double slit experiment, just as in my d squared non-orthogonal slit experiment, there are two experiments. One with the switch off and one with the switch on. So the one with the switch on is that you have a particle detector here and a particle detector there. And the usual way of describing having the detectors is if you look at the pattern that appears on the screen, it's these two Gaussian lumps. So you would say, oh, yeah, I do use the usual laws of probability right then and there, but that refers to one experiment. A different experiment is to take the detectors away, and now one gets the interference pattern. Feynman described this as the laws of probability being changed, And really what I'm doing is saying, no, it's not that the laws of probability are being changed, but that this is one experiment where the law of total probability applies, and this is a different experiment. There's no way to write down whether it applies or not because there aren't two experiments being done in this. Quantum theory, on the other hand, gives us the glue for putting the probabilities in the one experiment in terms of the probabilities in the other experiment. And that is not contradicting the law of total probability, but rather it's adding an extra thing that one might not have expected.
So it seems like when you added these R's, so the R's would be in the double slit experiment, either the top or the bottom.
That's right.
Splits. And I guess the bi-matrix, this is recasting the quantum mechanics formalism without complex, or without complex numbers? I mean,
That's right. So the thing on the left is a set of numbers that are all non-negative and sum to 1. The thing on the far right is a set of real numbers. Did I say complex here? I didn't mean that. I meant a set of real numbers that are non-negative and all sum to 1. Over here on the right, that's a list of numbers that are non-negative and sum to 1. The thing on the left are conditional probabilities. Again, they're probabilities, so they're non-negative and they sum to 1. But you've got this other matrix in the middle made of real numbers, but some of them can be negative. So there's negativity in this representation, but the negativity is in how the probabilities are connected to each other.
Hi, thank you for this. I have a feeling I'm about to ask a metaphysically dumb question, but I'll try for it anyway.
You're talking to a physicist. It can't be dumb.
Okay. So quickly, I think a lot of the interpretations of quantum mechanics, from what I understand, is an essential divide between macroscopic and microscopic systems, right? But in this description, it seems like using this probabilistic framework, now this kind of indeterminacy that you're talking about is applicable to anything that can be probabilistically explained, right? So if that's the case, I mean, maybe this is not a problem, but for example, we normally think that if I'm testing for a disease, for example, right? I have the disease and I'm just updating my priors by doing more tests, et cetera, et cetera, et cetera. But what you're really saying is, it's completely indeterminate if I have a disease, and the disease is only coming about kind of through the process of the actual testing. So, I mean, maybe I'm just kind of too entrenched in kind of an epistemic read of probability that, there's a there about whether I have a disease, and I'm just updating my priors to figure out the reality that's there. But are you making this even on a macroscopic scale, the idea that through the process of my testing, that's actually the manifestation of whether I have the disease or not?
No. So the point of view is to stop talking about the facts that are there and talk about the experiences. So if I am the doctor doing the testing, I'm trying to get a read on what experiences I will find. What I'm saying is silent on what you are intrinsically. Instead, it's just about, oh God, I'm starting to sound almost Buddhist. It's silent on what you are intrinsically, and then the next step of QBism is to say, well, there wasn't ever that intrinsic there to begin with, probably. So it's not that the whole world is coming about because of my actions, but some of the world is coming about because of my actions, namely the ones that I'm involved in. Now, how do we get the impression that, so you said you were epistemically invested. How do we get the impression that there just is stuff there? And in certain situations, even with this equation that just happens to be up right now, if your probabilities are not too sharp, you can rejigger them so that you can make this expression look like the law of total probability after all. Now, in some foundational games, people invoke decoherence. Decoherence has made this possible so that you can treat it classically. From the QBist point of view, it's not about decoherence. It's just about if you are sufficiently unsophisticated in your probability assignments, then you can rejigger them so that this does look like the law of total probability. And when it does, you can act as if, Gertrude Stein, you can act as if there is a there. And so you have the option. You can think in the crazy way. You can think in the William James, John Dewey way of they're not, that the world is constructed from experience, pure experience. Or you can think in the usual realist way, that there just is a world there. You got the option to go both ways. When you get to extreme quantum phenomena, one of those options starts looking less attractive. It has to be more rigged, like I would think that the Bohmian interpretation, for instance, is.
Thank you so much.
Sure.
I'm sorry I have to cut the discussion further, but Chris will be available for more questions.
If you'll buy me beer, I'll talk all night.
Thank you for inviting me here. I'm sorry that I can't be here in person. As I'll explain, my talk, I think, fits very naturally after Chris's talk. Hi, Chris. I enjoyed your talk, although I couldn't see your slides very well. But I think I have such a sense of your viewpoint now, because we've had so many enjoyable opportunities to talk about it in the past. This talk is based on a paper I've written, which is going into a volume, an OUP volume called Neo-Pragmatism, edited by Josh Gert at the College of William and Mary. So let's start off with the question, what is Neo-Pragmatism? And I'm going to introduce that with a couple of examples, a couple of reference points for which at least people who come from a philosophical background will be familiar with. A couple of examples, and I'll mention these people again later in the talk. The famous views of Hume and of Ramsey on causality. In both cases, what those philosophers offer us are what Ramsey himself calls a psychological analysis, not a metaphysics. So it's not a story about what causation is, but a story about how causal thinking arises in creatures like us. And this shift from metaphysical analysis, asking what something is, what the nature of causation is, say, to psychological or linguistic explanation is the core of what I call neo-pragmatism. And in many other places, I also call it expressivism. Another reference point in the terminology that we have from Wilfrid Sellars, neo-pragmatism is always seeking to explain some aspect of how the world looks to us. That's Wilfrid Sellars' manifest image in terms of some feature of us. So in Ramsey's case, for example, Ramsey's trying to explain the causal character of the manifest image in terms of the epistemic viewpoint of a deliberating agent. It's a very similar program, although in some ways more general than Chris's program in quantum mechanics. Or to give you one more metaphor, Kant's Copernican metaphor, the neo-pragmatist is interested in explaining apparent structure in the world, what we take to be structure in the world, as in part an artifact of our viewpoint. So that's neo-pragmatism. An important question for neo-pragmatists is, how far do we go? Is neo-pragmatism a local view, applicable to some concepts but not to others? Or is it global? Is there a pragmatic ingredient in all our concepts, as William James thought? A famous line from James, the trail of the human serpent is thus over everything. So my argument is that thinking about the temporal aspects of language and thought supports James's global conclusion. If I heard correctly, Chris said at one point at the beginning of his talk that I wasn't a pragmatist enough. My reply is, well, I'm a pragmatist about everything. What else is there to be a pragmatist about? Originally, I hoped to get there. I hoped to call this talk 5 Steps to Global Pragmatism, because I wanted to connect it to James's metaphor of the human serpent. And I knew that everyone here would be familiar with 5-headed serpents. But then I had a struggle. I really wanted to fit in the sixth topic at the end, and who's ever heard of a six-headed serpent? So that was a tension for a while, but sort of logic won out over metaphor, and so it's the talk is really 6 steps to global pragmatism. And the character of these steps is that they're taking us from very narrow topics at the beginning to very broad topics at the end. So it's a pathway towards generality, or a pathway towards the global pragmatist picture that I want to defend. Very late in the day, when I was revising these slides, I came across this wonderful 6-headed serpent. So I got my metaphor back, and this is a particularly good one, because you see this has become a 6-headed serpent by deletion, and the one that's been deleted is the one who would have claimed to being some sort of super observer in Chris's terms. And one thing I agree with Chris about is that there's no such thing as a super observer. Okay, so that's where we're going in 6 steps to global pragmatism. First step, the temporal indexicals. Consider terms like now and various synonyms for it, like the present, terms such as yesterday, today, and tomorrow, and tensed expressions in language in general. These expressions, philosophers call them indexicals. So the job they do in language is to indicate the temporal location of something in relation to our own temporal location at the time of speaking. Those are temporal indexicals, and other kinds of indexicals do a similar thing with respect to space, the terms like here and there, or with respect to personal identity, terms like I and our and you. Now, for the spatial and personal indexicals such as here and I, almost everybody is a neo-pragmatist. So almost nobody thinks that in using these terms, we're talking about some distinctive aspect of the world, an objective here or an objective me. I mean, in the latter case, it's only solipsists who think there's something objective there. But many philosophers and some physicists think that the temporal case is different, that there really is an objective now in a sense in which there isn't an objective here. Neo-pragmatism recommends treating now like here and explaining the use of tense language without requiring a distinctive subject matter. There are long debates in the philosophy of time about the advantages of that, and it would take me too long to explore them here. For my purposes, what's important is that this is one small step on a pathway towards a much more general view. Second, now generalizing to other aspects of time and stealing the title for this step from Craig Callender's wonderful book, What Makes Time Special. Here are 4 ways in which time seems to differ from space. I mentioned one, the apparent reality of the present moment. There's the sense that time passes or flows. There's the difference between the fixed past and the open future. And there's the sense that time has a preferred direction. These things, perhaps, or most of them are perhaps intuitively linked in some way, but I think it's worth pulling them apart. And my recommendation is to be a pragmatist about all 4 characteristics. Again, I'm not going to defend the view, but I'm going to give you some examples of people defending parts of it. First of all, here's Russell and Ramsey on the difference between the past and future. Russell first, this is from Russell's famous lecture on the notion of cause from 1913. Russell says, we all regard the past as determined simply by the fact that it has happened, but for the accident that memory works backwards and not forwards, we should regard the future as equally determined by the fact that it will happen. So there's Russell saying that the apparent difference between the fixed past and the open future is just a product of the fact that our memory is asymmetric between past and future. I'm not defending Russell, I'm not claiming that he's right about that, but I'm just offering him as an example of somebody who's taking what counts as a neo-pragmatist view by my lights. 15 years later, here's Ramsey, who says, it seems, a fundamental fact that the future is due to the present, but the past is not. What does this mean? It's not clear, and if we try to make it clear, it turns into nonsense or a definition. After some more discussion, he says, what then do we believe about the future that we don't believe about the past? This seems to me to be the root of the matter. That I cannot affect the past is a way of saying something quite clearly true about my degrees of belief. So again, Ramsey's giving a psychological explanation of what we naively take to be a feature of reality independently of us, this sense that the future is open and the past is fixed. I think I discovered just very recently when I was writing a review of Cheryl Misak's wonderful new biography of Ramsey, that Ramsey probably got this question from Eddington's book, The Nature of the Physical World, from the previous year, because it's known that Ramsey read Eddington's book, which was a bestseller during 1929, and Ramsey wrote the text I've quoted in September 1929, 4 months before his death. And those of you who know Eddington's book will know that Eddington devotes a whole chapter, more or less, to this question, although he doesn't have a solution himself. That was about the difference between past and future. Here's Boltzmann on the direction of time. Boltzmann isn't actually endorsing the view at this point, but he's certainly putting it on the table. For the universe, the two directions of time are indistinguishable, just as in space there is no up and down. In my view, it's very hard to make sense of what it would be for time to have an intrinsic direction, at least if we want to connect that fact to our ordinary dealings with time in physics and in ordinary life. But it's easy to explain why temporally oriented creatures such as us, all sharing the same orientation, should think of this as an objective feature of an environment, as our ancestors did with up and down, at least before they started traveling very much. And here, recognition of this perspectival element, the pragmatic element, has its usual Copernican advantages. It's avoiding a need for structure in the world by explaining the appearance of structure as an artifact of our viewpoint. Okay, step 3, generalizing from time, pragmatic treatment of time, to what I'll call the temporal modalities, namely causation and probability. In both cases, I think there are two big things to explain. One is the connection to rational decision. This is what I call the practical relevance constraint. And the second is the temporal orientation. That is the sense that the past determines the chance of the future, and the fact that effects are typically taken to precede their causes. So for both of these notions, probability and causation, they're both linked to decision in important ways, and they both seem to have a temporal hour or temporal orientation to them. In the case of probability, the practical relevance issue is well known, and it goes back, well, even further than Divinity, who Chris mentioned, goes back to Ramsey. Ramsey, for example, objects to Keynes's objective probability relations, that such relations would, quote, stand in such strange correspondence with degrees of belief, and hence with action. In other words, he was objecting that Keynes's account of probability left out the connection with degrees of belief, and hence with behavior, betting behavior. 20 years later, William Neal says that knowledge of probability relations is important chiefly for its bearing on action. And again, the central kind of action can be characterized in terms of betting behavior. As Ramsey says, all our lives we are, in a sense, betting. 20 years later again, Humela says, it must follow from our account of chance that the greater the known chance of an event, the more reasonable it is to act as if it will occur. And a bit later again, David Lewis, perhaps the greatest metaphysician of the 20th century, says, I wonder whether anyone but a subjectivist, which means, roughly speaking for our purposes, a neo-pragmatist, is in a position to understand objective chance. So this message that any story about probability or chance has to explain its relevance to action it's well known. It's familiar in the literature on probability throughout most of the 20th century. But in the case of causation, it's hard to find the equivalent point. Many philosophers think that we need objective causal relations to explain rational action. But here too, there's a neo-pragmatist tradition, again dating from Ramsey, and this explains causal concepts in terms of the agent's perspective. As Ramsey puts it, from the situation when we are deliberating, seems to me to arise the general difference of cause and effect. And in other work, I've argued that this approach provides the best explanation of both the issues I identified earlier, the connection with action, the practical relevance constraint, and the apparent temporal hour of causation. Okay, step 4. Step 3, we were talking about something much broader than time, but sort of still a relatively narrow set of categories, namely probability and causation. Now let's move to something broader, the category of dispositions. What is a disposition? Here's a quote from the Stanford Encyclopedia. Dispositions are those properties picked out by predicates like is fragile or is soluble, alternatively by sentences of the form X is disposed to break when struck. Dispositions so understood have figured centrally in the metaphysics and philosophy of science of the last century, and also in influential accounts of the mind. In ascribing a dispositional property, we commit ourselves to an expectation about how the object would behave in certain circumstances. So if I say that the sugar cube is soluble, I commit myself to the expectation that if I put it in water or my coffee, it will dissolve. But expectation is a psychological notion. Where should we look for an account of the psychological relevance of dispositional properties? And again, this is the practical relevance issue. And again, we can distinguish two approaches. There's the metaphysical approach, which takes on board the task of explaining the psychological relevance in terms of the nature of dispositions. So any metaphysical account of dispositions needs to explain how knowing about them can justify us having expectations. Or there's the neo-pragmatist approach, which begins at the other end, saying that we develop these descriptions because they're what we need as epistemically limited creatures concerned about our future welfare. So in this case, the expectational character of the manifest image, the fact that the manifest image is an image of a world of dispositions, is grounded in our own psychology and temporal character. Now, in this case, neo-pragmatism has a long and distinguished history. Some landmarks, I mentioned Hume on causation at the beginning. So Hume's view on causal necessity, at least according to some Humeans, there are disputes about this in the history of philosophy. But on the view I'm thinking of, Hume thinks of causal necessity not as something in the world, but as a projection of expectations acquired as a result of our observation of regularities. A less well-known example, but a nice one from my point of view, because it comes from a period when Wittgenstein was clearly influenced by Ramsey. Wittgenstein says, this is in some lecture notes from early 1930, when I say there is a chair over there, this sentence refers to a series of expectations. That's the other reason I picked it, because the word expectation actually appeared here. I believe I could go there, perceive the chair and sit on it. I believe it is made of wood and I expect it to have certain hardness, inflammability, etc. Jumping forward a bit, another 20 years, there's the views of Gilbert Ryle, the Oxford philosopher, here described by Alexander Bird. So Bird says, according to Ryle's view, the sentence, this lump of sugar would dissolve if placed in water, does not assert some factual truth, such as the attribution of a property to a thing. Rather, along with law statements, such assertions must be understood as inference tickets. What one is entitled to infer from this lump of sugar is in water to this lump of sugar is dissolving. So Ryle is thinking Raoul's view there is that dispositions are they're not genuine properties, they're these inference tickets, as he puts it. One more landmark. Some of you will be familiar with Bob Brandam's inferentialist picture, which puts the dynamical character of dispositional concepts at the core of all empirical concepts whatsoever. This is a view inspired by Kant via Sellers, and it replaces the Humean habitual conception of the psychology involved with a normative one. So concepts are understood in terms of their role in the dynamic behavior of norm-governed inference engines. So that's a slightly different version of the pragmatist view because of this shift from the habitual conception to the normative conception, but it's still very much in the same ballpark. So the neo-pragmatist conclusion then at this point is that at least a major part, if not all, of the properties we ascribe to the world reflect the temporal character of human thought, in particular of our striving to prepare for an uncertain future. So in this way, our own temporal character is reflected in our image of the world we inhabit, both in science and in everyday life. And again, these are pragmatist lessons. They require that we reflect on our own natures as physical entities of a particular kind, processes embodied in time, in which each stage has an interest in later stages. That picture needs to be more complex. It needs to bring in the fact that we're not mere observers, we're also agents. But I think the general pragmatist orientation should be clear. Step 5, we're almost there. Now, I quoted Wittgenstein earlier saying every sentence we utter in everyday life appears to have the character of a hypothesis. Wittgenstein goes on in the same passage, the representation loses all its value if the hypothetical element is dropped, because then the proposition does not point to the future anymore. Among other things, this is a kind of indication of Wittgenstein turning away from his own Tractarian picture theory of meaning. Here he's thinking of the way our descriptions build in expectations. But time is also relevant to language in a more basic way, and that's the thing that I want to pull out at this step. When we use a sign, it's a gift to the future in some way, something that we put in place for later use by someone else or by our later selves. And the fact that we can do that depends on the fact that we're all disposed to produce and interpret signs in pretty regular ways. So there's not much variation between us or individually over time. And we're all familiar with squirrels putting away food for the winter. Now imagine that squirrels were disposed to eat very different things at different times of their lives over a time span of a month. And of course, it would be no use them burying a nut in October if by the time they get to January, they don't like nuts. And there's something similar that's obviously true about language. There's no point in writing a note on your hand to tell you what you have to buy at the supermarket, unless you're going to interpret that symbol that you put on your hand in the same way when you get to the supermarket as when you put it on your hand. This is a point which comes out in philosophy in the famous rule-following considerations from Wittgenstein, and particularly from Kripke's interpretation of Wittgenstein. And those considerations turn on the observation that no finite amount of training can guarantee that two speakers won't diverge at some later point. But what all of this reveals is the sense in which all of language depends on contingent facts about us, contingent temporal facts, facts to do with constancy over time. And so it provides a further argument for global pragmatism. And in the part of this to do with the rule-following considerations, that's a point I made in my book, Facts and the Function of Truth in 1988. It's also made by Philip Pettit a couple of years later. Okay, last step. And at this point, I'm going to really stop talking in my own voice and just give you some suggestive quotes from other people. Where we've got so far, I've argued that at all three corners of the mind, language, manifest world triangle, that is in concepts, in terms, and for properties, we found marks of the kinds of temporal creatures we are. I've all argued that these are deeply neo-pragmatist conclusions. To finish up, I want to mention some recent developments in the science of the mind that seem to push this viewpoint even further, with further implications for pragmatism. Here's a quote from Jakob Howie, who's one of the leaders in philosophy of this field, writing about what's now called the predictive processing framework. Howie says, a new theory is taking hold in neuroscience. It's the theory that the brain is a sophisticated hypothesis testing mechanism, which is constantly involved in minimizing the error of its predictions of the sensory input it receives from the world. This mechanism is meant to explain perception and action and everything mental in between. It has enormous unifying power, and yet it can explain in detail too. Another quote from Andy Clark, another of the leading writers on this. Clark says, creatures deploying this kind of strategy, the predictive processing strategy, learn to become knowledgeable consumers of their own sensory stimulations. They come to know about their world and about the kinds of entity and events that populate it. Creatures employing this strategy, when they see the grass twitch in just that certain way, are already expecting to see the tasty prey emerge and already expecting to feel the sensations of their own muscles tense into pounds. An animal that has that kind of grip on its world is already deep into the business of understanding that world. You can probably see that what I like about this idea is the way in which this kind of expectational character of our thought that I was talking about earlier is becoming the essential feature of this powerful framework for neuroscience. One more quote, this is from a young Cambridge philosopher, Dan Williams. Williams says, the initial appearance of a deep conflict between pragmatism and predictive processing is illusory. Far from an image of minds as passive spectators on the world, predictive processing advances a fundamentally pragmatic brain, striving to maintain the viability of the organism under hostile conditions, and in so doing, actively generating an effective niche, an experienced world structured by the idiosyncratic practical interests of the organism. What emerges, Williams says, is something much closer to Price's metaphor of a holographic data projector. I won't try and explain that metaphor here. Much closer to that than a passive reflection of an independently identifiable world. As Clark puts it, it's a vision of experience that is maximally distant from a passive mirrors of nature story. So I think that's a confirmation that this exciting work in neuroscience is a further confirmation of the basic pragmatist viewpoint that in order to understand language and thought, we need to understand the huge ingredient that comes from us. We're not passive observers of a reality to be investigated in metaphysical terms. Okay, that's basically it. So here's William James, and here are our 6 snakes, and I hope I've given you a sense of how I see the two to be connected. Thank you.
Hi, you. I kneel.
Hi, Carlo.
I'm kneeling in front of you.
Well, that's not necessary. We can tilt the camera so you can stand up.
Maybe is this better for you? Whatever.
Yeah, now I can hear you properly.
Okay, so in fact, kneeling is appropriate because I have a question, which I'd like you to take in some sense a question for this disciple, how do you say it? It's a very specific question. It's a specific part and a general part.
you probably know that. I very much appreciate your perspective, and I sort of read what you write as really as a physicist who read the philosopher, and try to use this perspective that you provide, and has long been like that for me since long time. Now, I very much follow and adhere to this, that you call the pragmatist way of understanding a number of things by interpreting them by relating us to our understanding of ourselves in the way you describe. And I'm going to a specific question. But it seems to me, and that's a point, that you're sort of underplaying a part of the story, and I don't understand if I'm adding too much a part of the story, or if you just underplaying this. When I think of the Copernican revolution that you mentioned at some point, I do understand a huge phenomenon, the turning of the skies around us, by understanding as a perspectival aspect. They say, oh, that's just something happening to us. That's perfect. But I'm also capable of giving the full story of we sitting on a rotating rock, so and so and so. And the same with up and down. I understand the structure of the world, which is the up and down, by reducing it to our particular position on Earth. Now, if I do the same with the phenomenon that you're mentioning, and specifically the direction of time, the orientation of time, I have to, of course, say, look, I understand it by reducing it to the fact that we, obviously time-oriented creatures, do this and this and that. But it seems to me that this, I'm a scientist, I'm not a philosopher. This for me is a research program, not an answer. The research program being, why are we creatures in this world time-oriented this way? And let me be more specific. One of the most striking aspects of the orientation of time is the epistemic aspect. Remember the past and not the future. So this for me is an opening of a question, which is how come that in the world in which we are, which is sort of thermodynamically oriented, and let's take this contingency fact, how come that there are memory traces of the past and therefore memories of the past, so that I do remember the past, and so that because of that I think in terms of causality and so on and so forth. So there is less. Now, that's a specific question to you. Am I doing the right research program? That's one of the main things I've been doing recently, is exactly trying to fill in this gap. Or am I stepping out from your pragmatism into a naturalism where, and I guess this is the philosophical question to you, is your pragmatism within a naturalism in which you're saying within a naturalistic point of view, that's the world, and the part which seems strange from a naturalist perspective, from your perspective, I can understand it perspectively, or you're being a pragmatist here by saying, let's take as primary my own experience because it's given and obvious to me and built out of that. Is that the question clear, or is it too confused? I'm not sure.
I think so. Let me try and answer it, and then you can tell me if I've missed something. I completely agree with you that there's a big and fascinating untold story about, roughly speaking, about how the fact that we live in a time asymmetric thermodynamic environment produces the kind of creatures that we are. And that's a fascinating story at many levels. I mean, part of it must presumably be a very basic story about the nature of life. And then there are presumably higher level bits about cognition and predictive processing and agency and so on. I think it's probably a kind of story where we can approach from a number of directions. And one of them that I know that you're doing in your recent work, and that people like Jared Milburn are doing too, is sort of approaching in a formal way by trying to characterize the notion of agency, say, informal terms and relate it to thermodynamics. I think that's all fascinating work, and it is certainly part of the kind of pragmatism that I have in mind. And what that means is that of the two views you distinguished at the end, it's much more like the sort of pragmatist done from a naturalist perspective than a view which, as it were, treats the sort of subjective viewpoint as primary in some way. But where I differ from a lot of naturalists is in really taking seriously the idea that it goes all the way down. And so there's no sort of pure scientific language which gets distilled out, which doesn't have any pragmatic ingredients in it. And so there's a sense in which, at the scientific level, I think of the pragmatism as a kind of rolling program, and this relates to one of the ways in which I differ from Chris. So unlike Chris, I'm much more interested in the question, as it were, what kind of world would look the way that quantum mechanics looks to us? So that's in effect accepting the QBist part, but asking the question that he doesn't want us to be able to ask, if I understand it correctly, about how some other conception of a world underneath could produce that appearance. But then if we get a theory of that world, it can't escape from pragmatism either. I mean, because of the way in which, as it were, the pragmatic elements in any language whatsoever. It is, I do want to be serious about the global nature of the view and the fact that it's kind of inexplicable. Inextricable is what I think I meant. We can't get outside the pragmatism, but that doesn't stop us asking the naturalistic questions about as it were, about the appearances at any level.
Yeah.
Does that help?
Yeah, very much. I think it articulates the two perspectives altogether. Thank you.
Yes. I'm sorry I'm not kneeling. I got terrible. Thank you very much. That was a lovely talk. So one question for you about your this balance between pragmatism and naturalism. So one thing that I'm struck by, and I'll talk about in my talk on Sunday, I'm going to use this, bring up this metaphor of the movie Arrival. In the movie Arrival, you have these aliens that come down and land, and they send a physicist and they send a linguist to try and communicate with them. And the physicist tries the usual thing of like, oh, I'm going to teach you math because math is universal, and it fails utterly. And then the linguist, who understands sort of how language is representational, she's the one who's able to communicate with them. And the most important part for me about that is that these creatures who have originated with a different embodiment, who being as you say, a particular kind of creature in the world, have an utterly different experience of time. In some sense, their physics of time is very different. And I wonder about this quite a bit. And so this is sort of this difference of like, okay, you're a kind of creature, like whatever process made you a kind of creature, parsed the world out in a way that you end up with what you think is a certain kind of physics. And if you were embodied in a different way, would you perhaps that split between self and world have formed differently so that, in the infinite book of nature, you ended up with a slightly different or a very different sort of, sense of what is naturalistic? Would that fit within your idea, or is there always, we're going to want to say there's this bedrock?
No, that's a lovely question. I think to some extent we can make sense of those sorts of variations. Well, perhaps I should say first that in order to answer that question, I think we're going to need the kind of work that Carlo was talking about, of better understanding the details of as it were, what it takes and how it depends on the physical background, thermodynamics, and so on, to get creatures of the kind that we are understood in some various abstract terms. Once you understand that, then you can start thinking about, well, what other possibilities are there for something that you might think of as cognition and agency and so on within that framework? And if there are other possibilities, would they, as it were, develop different physics? You could then get to the question you wanted. Now, I think there are some sort of fairly easy options which suggest that, at least in some respects, the answer is going to be yes. And the one that I've often used, I mean, as far as we know, from the point of view of fundamental physics, it's possible that there are regions in the universe in which the thermodynamic gradient points in the opposite direction. That was actually what Boltzmann was talking about in the passage that I quoted from. And as Boltzmann says, creatures in that region would think of time as going in the opposite direction. So their conception of causation and the open future and so on would sort of be like ours, but just pointing in the opposite direction. So that's already a step towards the kind of possibility that you were thinking of. And I think we can make sense of that one, just as we can make sense of the people. Once we understand that the Earth is a globe, we can make sense of the idea of people's sense of up and down being different at different points. So if you point up and I point up, we're pointing in very different directions.
Hold on, I'm going to get.
Yeah, okay.
It's on the same exact question. I just wanted to make a comment, see what you think of it. Would you say that it is a universal, going back to the arrival of creatures, is a universal prerogative of life, at least for creatures that have a certain level of cognitive complexity, to be able to remember the past so they can survive in the future?
My guess is that something like that is going to come in very early in the evolution of life, and it's basically an adaptation to the environment. Where precisely that happens is going to depend on, as it were, it's going to depend on the environment, because it's going to depend on the environment what sort of payoff there is for something like something which functions like memory. But it's presumably going to be very, very basic.
Hi, Hugh. Good to see you after a long time. It was a lovely talk and a wonderful weaving together, I thought, of Hume and Heidegger in a surprising way. And I wanted to just ask you about the one place in the talk where you really surprised me. And that was in your approval of Bob Brandam's remark and the view that's so common among folks that somehow replacing a Humean account of normativity as grounded in custom and habit, the pragmatist understanding, with the Kantian transcendentalist account of normativity as kind of given by reason is an advantage. And I would have expected you to regard Brandam's move as an error, and instead you seem to approve it. And that surprised me. Do you want to talk about that a bit?
Oh, yes. I didn't mean to cite it as anything other than one of my, I think it was 4 examples of this within that general category. Was it step 4, I think? Do I approve it? Well, there are certainly some things. I mean, there's a sense in which I want to be a Humean underneath, but I'm nevertheless interested in, as part of the general pragmatist Humean picture, explaining the origins of normativity in our lived life.
Yeah. You think that the right way to explain, I would have thought that you would have agreed with me that the right way to explain normativity is as a set of practices emerging from custom, from convention, from our lived life, rather than a Kantian transcendental origin.
Oh, okay, yes, no, I definitely agree with that, and I've sometimes sort of disagreed with Bob effectively on the point of being frustrated with his unwillingness to sort of try and dig down into the Humean layer.
Yeah.
So in that sense, I'm on your side.
I'm relieved. Thanks, Ewan. It really is good to see you again.
Yeah, you too.
I am invited to close the session and thank you, Hugh, for this very nice presentation, and also I thank you everybody because it was an extremely smooth hybrid session. It worked very well. So thank you everybody. And let's thank you.
Okay. Well, thank you for having me. I really enjoyed it.